And I have no idea how many people are going to show up today. It doesn't matter. I'm gonna teach it anyway. And by the way, yesterday was the hard day. Today's kind of just like coasting along, easy and smooth. And there's still a lot of material, but yesterday was the hard day. I intentionally configure it that way. So
Bring it up hard so it ends up easy, and we feel, whoo, got
yeah.
you.
So who here has scheduled an exam?
Me.
All right. When's your exam and who are you doing it with?
Next Wednesday, and I'm doing it with the Anchorage, Alaska.
Good. I love those. I love them. I work with them quite a bit. Who else has an exam scheduled? I don't hear a lot of answers here. Who's got an exam scheduled?
Mine's not scheduled, but I'm doing a walk-in
I
next
see that.
Saturday.
Yeah, okay. Nobody else?
What's a walk-in?
Like in
Where
person.
Yeah, you just show up and they issue you the test. Doesn't
Oh,
require registration, but I might between now and then anyway.
Yeah, I see some of the tests for distance or online. 10 minutes heads up. I doubt that, but
No, it really is.
I'll kill mine on either Sunday when the wife's out or Monday when everybody's at work. And all I have is a cat over here to bother me.
Yeah, I installed the app, the question app. That's a good hint. But I did some test runs and I'm not ready yet, so I need to study more.
that's true. That's very true.
I've learned with the app, if I don't understand it, I've memorized the question.
That works. If you go
So
through them all.
Yeah.
I started taking the test with a Alpha Alpha 9 Papa Whiskey,
Yep, so that's Simon.
and then I've taken the test from one other website, which puts it in a different order. Some of the questions they're not different. The question or the answers are slightly different on one of them, and I've learned to actually, while I may not understand the why of the question, I get the question right because I understand the trigger words like current and flow. So however I get over the horse.
Well, here's the thing that when you get to the exam, you're probably not going to remember every single question. I mean, there are 450 of them, right? If you go through and you go through every section and you study every single question over and over and over and over, you're still probably not going to remember every single one. But what you'll get is, okay, so if you have four answers, A, B, C, and D, how many of them are really like humorously wrong?
Probably two.
Two of them are humorously incorrect. If you have any knowledge of the subject at all, you can basically eliminate two of them immediately because they're just so ridiculous that they don't make any sense. And those are really there to see if anybody has even paid any attention when they were studying.
And just be thankful it's not like the National Registry, because they give you the National Registry of Emergency Medical Technicians. It's the toughest test, even beats MCATs for medical. And I aced that with a 98% for my paramedic, which that was a shock even to me. But you just go in and they give you four right answers, but you got to, out of those four, you got to pick the best one.
The best one. So in this case, two of them are really wrong, and one of them is more correct than the other one of the remaining two. So if you start looking through the exam questions, you will see that, now that you've heard these, at least, you've heard a lot of the stuff we're talking about. Two of them make no sense whatsoever.
How much do you got to score to pass a test?
74%.
Only 74? Oh, okay.
A C, basically a solid C.
What is that? 20?
It's a pretty simple.
20,
I mean, it is
26.
26 out of 35.
Yep.
I was telling him I took it my second time around and I missed it by 2 questions. I felt like a heel.
Well,
I
and the
just started screenshotting.
and it's the same score required for the general exam. So again, 26 out of 35. And if you get to the
Okay.
extra, it's 37 out of 50. So it's still that 74%.
So when you fail, is there a grace period? When can you try again?
You can do it immediately if you want.
Oh,
One
okay.
month later, I will.
You used to have to wait a month, which kind of stunk. So, and now you
My
can do it immediately.
Yeah, my first time was with the Fort Wayne, Indiana club. They came and did the testing at Finleyham Convention, and that's when I told you I was just out of surgery. I was high on narcotics, and I didn't care what I got.
Yeah.
You
By the
know,
way, I would like to point out, remember Sean yesterday was kind of muffled? If anyone is curious as to why I always recommend if you're going to do any kind of stuff using Zoom and Microsoft Teams and anything like that, this is why you get a headset.
Yeah.
For 20 bucks, it works so much better
Yeah.
than using that crappy little microphone in the computer.
The only thing is, after what did we do yesterday? 6 hours. After 6 hours, my ears are so hot.
Well, you need to live in Oregon. Where do you live?
I do live in Oregon.
You do? Okay. Well, there's no excuse then. This morning I woke up, it was 52 degrees outside.
I mean, okay.
Get a spray bottle of water.
Not in my
Yeah.
room.
alcohol wipes.
Yeah,
they
that
work
too.
wonders.
Yeah,
See,
actually,
you guys are complaining. It's 85 here and 100% humidity, so it's
already.
like 102 outside.
That's right.
Yes.
Yeah.
You got to remember it's technically noon here in Ohio. So
Yep. It's 100.
Oh,
It's
Mojave. No. It's a dry heat.
dry heat. Yeah. All right, everybody ready to get started? Is everybody okay? So before we get going, what we want to know is please ask your questions. I know there's some questions. There have to be some questions after yesterday. I hope everybody was able to, if they really wanted to, if they weren't totally burned out, to go back and look at the video. I sent out a link to that last night. Hopefully everybody got it.
I haven't received it, or I haven't looked that I've to see if I've had it. I've received it, but I just want to say that this is like learning a whole new language.
Yep, sure
I
is.
get some of the trig stuff, but the electronics, I'm gonna have to study with all that, and all the symbols and stuff. So yeah. But I really appreciate you putting this on.
You know what I really
Regular exposure.
recommend? What I'm really going to recommend is you don't have to know everything. You really don't. You don't have to remember everything. What you have to do is, and this is what I tell people who are studying for the first time, go and study up for and practice the test, and then go take the test. And once you're on the air, that's when you actually start understanding all that stuff that we really did, right? There are people who like to do, like academics, right? I'm not a huge fan of learning for the sake of learning. I want to learn for the sake of doing. And in this particular case, all that book stuff, I mean, look, I went through engineering school, right? Bachelor's and master's degree. Most of that stuff that I learned, yeah, I had to learn it because they told me I had to learn it. I didn't understand it until 15 years after I was done with school because I actually got to apply it. Then it made sense. Like, well, why didn't they tell me that? Why didn't they tell me any of this stuff? Like I look back and I can see, okay, well, all that calculus I learned, all that stuff that I had to learn because I had to learn it. Well, sure, they taught me the mechanics of doing calculus, but they didn't actually tell me why. I mean, or it was so embedded in, all the other stuff we were learning that they just never really focused on it. But now I look at it and I actually use it to solve real problems. It's been 35 years. Would have been nice to know that I was going to use it. So, get the license, get done with the exams, go hang out with your local club, do stuff, get on the air, and by the time you're done with that part of it, then you go back to this and you know all the lingo. You know that you'll understand the terminology because you've been speaking it for the last month or two. It will make so much more sense. But go take the test. Don't say, I don't understand this, so I'm not going to take the test. Right? That's not where I want you to go. I want you to get to the point where you say, I don't understand this, but I have enough confidence in myself to understand at least a little bit to the point where I can pass a test and start doing things.
Well, the confidence factor is what's the problem for me.
Well,
I
but
second guess myself.
have you been
Me too.
taking practice tests?
Not yet.
Okay, well,
Maybe.
you need to start studying the exam. And I know that's maybe a little bit controversial, and for some people there's some kind of stop in their head that says, I don't really understand this, therefore I don't want to take the chance and take the test. I will tell you that I went into every month as a 17-year-old when I was in college. I said, okay, well, I passed my 20 words a minute. I got to go take my technician, general, advanced, and extra. I'm going to do it in 4 months. Every month I bought the book for the next exam and I read through all the questions, and it wasn't really an explanation. It was, okay, well, I got to go through and I have to pass. And I don't really understand the material that well, but I'm sure that someday I will. And that stuff that we talked about yesterday. Does everybody remember the RMS voltage that I was talking about? Remember we talked about that very briefly? Basically, that's a power average for a voltage waveform versus a different voltage waveform. I didn't know what that was. There was nobody who was teaching me that. I just got to it and said, okay, for a sine wave, it's a square root of 2. 1.4 times the peak. 1.4 times gives you the peak. You just got to memorize it. I hadn't had calculus yet. I couldn't calculate it. I didn't have a book that showed me how to do it, but I went ahead and did it. And then I actually got to use it. And then later on, I got to figure out exactly what it was that made it work. Same with peak envelope power, which is another thing that you guys will get to on the general exam. Figuring out peak envelope versus average power. At some point, you have to accept the fact that, you're not going to necessarily be able to calculate it because not everybody is that good at math. But there are going to be tricks that allow. This is not designed to be an engineering class.
Mm.
The amateur radio exam. My daughter got her license when she was 15, and she got her extra when she was 17. She doesn't know everything, but she has her extra class license. She went through it. She went through the process of studying and got an 82% on that exam, which is not an easy exam. And that in and of itself shows a desire to go ahead and at least try it. So that's what I want you guys to get out of this. The other part of it is that if it comes down to I really want to understand this, then you can go back and say, okay, I remember we did something like this, because I do teach the theory behind stuff. I mean, that's what I really like, but you don't have to remember it all. I mean, my wife got her technician license. She doesn't know literally anything. Don't tell her I said that. But she'll be the first to admit she's good at taking tests. She studied the exam. She studied the question pool, and she went in and got like a 95% on it. She just studied the questions.
I had a school friend like that. He would study right before the test, and he would ace it. And a week later, so he didn't remember simple things.
Didn't remember anything. Yeah, exactly. So, so actually, when I was in Canada about a year and a half ago, actually about 2.5 years ago, a friend of mine up in Canada had said, the next time you're in Canada, because I work up there sometimes, he said, you should study up for your Canadian exam. I'm like, well, don't you have to be like a citizen or anything? He's like, no, you just have to have an address. Like, oh, okay. Well, so I asked the guys at my work if I could use the address as a mailing address in Surrey, BC, and they said, sure, no problem. We'll forward it to you. So I signed up for it. I studied for 6 months for the Canadian license exams. And you know what? The rules and regs are different. Some of the basic stuff is the same, but the rules and regulations are different. It's a different country, different organization that runs it. I'm like, okay, I just got to memorize it. The question pool for the basic exam is 1,000 questions. The exam itself is 100. And you need to get a 70% to get a basic license and an 80% to get a basic with honors license, which is equivalent of a general license. But I gave myself time to do it. I'm just like, all right, I'm just going to practice it, go through it over and over and over and over and over. And yeah, that's how I did it. And then it turns out actually that the advanced exam, which is the equivalent of our extra class license, that's only 50 questions and 500 question pool. And it's all the math, like really heavy on math. And that was the easy exam for me. So, all right, you guys ready to get going?
Yep.
All right, so schedule that exam. Put a date in the sand that you can't get away from. Say, I am going to practice for this day. And that's your day. Because I have seen way too many people go through and you say, I'm going to do this eventually. And I can actually consider one of my greatest failures of teaching, one of my coworkers, who I'm not going to name, but he's a really good engineer. And he basically just said, I never really wanted to take the exam. I just wanted to learn the material. I'm like, dude, really? I can't get you to take an exam? Like, no. I consider that to be a personal failure on my part. So, all right. Here we go. Station setup and operating controls. We are on page 73. And let me just put this up on the screen. Okay, here we go. All right, so we have a couple of things going on here. When we set up a station, right? I'll just make sure we did. Yeah, okay, we did that. When we set up a station, one of the things that we want to do is follow Ohm's law. So Ohm's law basically says that when we are powering something, what happens to some of our voltage? Based on the resistance of the wire, some of the voltage goes away. It becomes a voltage divider. So let's say we're running a station and we're running a 100-watt transmitter. This is, you know what? Let's make it a 50-watt transmitter. That's a little more common for what we're starting on VHF. Okay, so a 50-watt transmitter. Okay, so what is a typical voltage we're going to be supplied by a battery or a power supply?
12.
Well, nominally 12, yeah. Actually, 12 volts is actually 13.8. That's a fully charged lead acid battery, 13.8 volts, but we call it nominally 12 volts. Okay, so that being said, by Ohm's law for power, what's my power formula for Ohm's law?
E equals I times R.
Well, there's E equals I times R. And what's the other one?
Equals I times E.
Yeah.
P equals I times E. Okay, so we have our pi, P-I-E. We make our pi. Okay, so what do we know? We know our power, right?
Yep.
So we can cross that out. And then we're left with I times E. So 50 is equal to I times E. And what's our voltage?
12 or
12,
13.8.
nominally 12 volts. So from this, I is equal to 4 amps. Okay, so in order to generate 50 watts of something, we would use 4 amps. In reality, however, this is not true. Because in order to generate 50 watts of RF and run a piece of equipment, we don't actually need 50 watts of power. We have to deal with something called efficiency. Most transmitting equipment is at best 50% efficient. So if that's the case, to run a 50-watt transmitter, how much actual power do we need to bring in?
Seems like 100.
Yeah, it's actually 100 watts. The other 50 watts, where do they show up?
Heat.
Okay, heat, that's a good one. Other stuff?
Loss.
Well, that shows up as heat.
Resistance. That's heat.
Well, that's heat. How about, does the thing have any lights? Right? You have a front panel display that has a light. Is there a microphone circuit that converts microphone energy, vibrational energy into electrical signals? Well, there's probably some amplifiers in there. Does it have a display, like a numeric display? Probably. So what runs the display?
Current.
Literally, what runs the display? If you're gonna have a computer,
LED.
you got LEDs, and what drives the LEDs? Tells them what to display.
Processor.
A CPU. Yep, exactly. All of that stuff fits into the fact that, okay, it's a 50-watt RF transmitter, but really it takes about twice that much power to actually run the thing, which means that in reality, that requires something around 8 amps.
So why don't they make that the actual power rating?
Because why would you buy something that is right at the edge? What if you were to hook something else up to it?
But I mean, if it's gonna take 100 and it's advertised as 50, why?
Well,
Why would-
because it's a 50-watt transmitter. That is the amount of power that's going out to the antenna. It is a 50-watt transmitter,
Oh, okay. So
but
that's
it requires 100 watts roughly to run the thing.
gotcha.
And in reality, it usually takes a little bit more. You want to leave a little bit of room. So the most common power supply you'll find is something that's between 10 and 12 amps. Essentially, it's got enough oomph to push 13 volts at 10 to 12 amps to run a 50-watt radio. So you start doing the math and you get 13.8 volts at 10 amps. And just do a multiplication. The volt times an amp is a watt if they're in phase. For DC, they always are. That's 138 watts, which is considerably greater than that 100 watts needed to run the radio, which means you can also run a desk lamp, or you can run some other kind of small piece of like a battery charger or something like that on the same power supply. Maybe some LED lighting. So when it comes down to station design, we take all of this into account. Now, the other thing is, things that we take into account are the fact that we now have this power supply, and how much current is being delivered to this radio when it is transmitting? How many watts?
50% of 50 watts.
Well, no, it's 100 watts, right?
Oh,
It's consuming 100 watts. Okay, so it's consuming 100 watts. We have to deliver something on the order of 8 amps. Okay, so now, how is that current delivered from the power supply to the radio?
Power cord.
Power cord. Okay, so we have a choice to make, don't we? Well, what can we do with our power cord?
insulated.
Yeah, okay. What else? Obviously, you don't want
Uh,
short circuits. That's bad.
Heavy enough gauge.
Ah, yeah, okay. So let's take a look at two different pieces of cable. We're going to take this cable and we're going to take this cable. Right? And this is just like a copper conductor. Which one of these is going to have a higher resistance?
The smaller cable.
The small one. Yeah, it's like trying to stuff a whole bunch of water through a tiny hose. So this is going to have a higher resistance. Which one now, if I'm going to do this, if I'm going to take two cables the exact same length, or sorry, two cables of the exact same dimension, and I'm going to do this with one of them. Versus this cable. Which one's going to have higher resistance?
The bottom
the spaghetti
Longer
one.
one.
And why is that?
longer
Um,
wire.
More
Because
wire.
it's like a
Yeah,
conductor.
right, because the conductor's longer. Conductor resistance is dependent upon its diameter as well as its length. And what that means is that the one on the bottom might have a resistance of 3 ohms, and the one on the top might have a resistance of 0.2 ohms.
are you also making some inductors there?
Maybe. Not too worried about it. It's DC.
Yeah.
Okay, so we have 0.2 ohms up top and 3 ohms at the bottom. Okay, so here's my next question to you. What is, for the top formula, where it's 0.2 ohms, how much current am I pulling to make that radio run?
8 amps.
8 amps. Okay, so for 8 amps, we're going back to Ohm's law. What's Ohm's law again?
P equals I times.
Well, there's P equals IE, and there's E equals I times R.
E
We're
equals
going to
I.
use E equals I times R in this case to start. All right. And now we have a current and we have a resistance. The resistance is in the wires. So we're just going to assume that, yeah, current has to go out and back. And all right, so we're going to figure out in this resistor, because a wire is not perfect, what is our actual voltage that takes that resistance and that current. So we're just going to do Ohm's law. E equals I times R. And what is my current?
8 amps.
And for the straight wire,
0.28.
0.2.
it's 0.2 ohms.
Oh,
So that's going to be 1.6 volts. Okay, for the bottom one, E equals IR equals 8 times 3 is
24.
24 volts. Okay, does everybody see a problem here? What is the voltage of my power supply?
12 volts.
12 volts. For the
Negative
bottom wire, how much voltage at that current will be dropped in that wire?
Well,
Twice that. In other words, it can't work. That will never work. That wire will never work to provide that much power, that much current to my radio. How about the one that's on top? How much voltage drop?
Point.
1.6 volts.
1.6.
Well, okay, so this radio might not be quite as happy with that because how much voltage was in the power supply?
13.8.
Or we'll start at 12, right? And we lose 1.6 volts in the cable, which means how much is left to run the radio?
11.4.
10.4. Okay,
Yes.
so that, yeah, the radio may or may not work correctly for that, right? So what we can do is, fortunately, we can adjust on a lot of power supplies. We can set this for 14 volts. And we then will have 12.4 volts available to run the radio. And guess what? The lights may dim slightly when you transmit on the radio, but the thing will continue running. Ta-da! So this means that when we're building a station, let's say we went out and we bought a 50-foot spool of wire and we just don't want to cut it, right? Because it's so pretty, but we only need 6 feet. What should you do?
Got it.
Cut it. Yeah, exactly. Actually, and that is a real world question. You know, like that kind of thing actually happens. I just don't want to cut my wire. You know, well, you know what? Cut the wire. You can always put it back together, right?
Solder.
Yeah, solder is
You're good at
fine.
crimping.
Yeah,
So
exactly.
You said the lights might dim on the radio. If you don't give it the full amount of power, will it like always try to transmit at the rated power, or will it draw power from the other components of the radio?
Well, I mean, all the components are going to experience the same voltage drop. I mean, that's Ohm's law. That's Kirchhoff's law. They're always going to experience the same thing.
Hmm.
So, like as an example of that, remember I said 90% of problems are solved by Ohm's law? Okay.
Yeah.
We have a 24-volt power supply. And it's sitting over here, and then we have a 30 meter, which is 100 feet of cable connected to a camera. This is a real world problem that actually happened at my work. And every time the camera tried to take a picture, it would reboot.
Is this a PoE?
It's not PoE, but it's power over the same communications cable. So it turns out that the camera has a whole bunch of built-in lights that flash when, you know, to illuminate the subject when you tell it to take a picture. And I looked at that, and this is 22 gauge wire, which is very, very, very small. And I looked at that and I said, how much current is that camera taking when it snaps that picture? And it was taking 2 amps. So this 22 gauge wire is rated to carry 2 amps. But it turned out that the resistance in that wire for such a long length, it dropped the voltage by 7 volts. So we were left with how many volts over here at the camera? If we started with 24 and we dropped 7.
17.
Okay, this camera has a voltage rating of 24 volts plus or minus 10%, which
Now,
meant
was that 24 volts without the flash before you knew
it
the
doesn't
flash
matter.
there?
It doesn't matter. It takes 24 volts plus or minus 10% to run at all times. That means you could go as low as 20.6 volts. So what was happening to the camera? Every time we turned it on to take a picture, it would draw 2 amps of current, the voltage would drop to 17 volts, and it would turn off. And then as soon as it turned off, it stopped doing that, and then the voltage was there, and it would boot back up. This is a real world problem. This actually happens. Ohm's law is the answer to 90% of the problems you're going to find.
It happens a lot in PoE too.
That's exactly right. Anytime you have small wires doing the exact same thing. Okay.
Security cams or door panels.
Yep. Okay, let's see. Computer radio interface for digital mode operation. Okay, so what we're going to talk about is how to interface a computer to any radio. Okay, let's take a look at a radio. How do you make a radio work? What do you have to do? You have to hook up power. So there's your power supply. And then you have this thing going out to something on a desk, which you talk into. What's that called?
A microphone.
That's a microphone. Okay. And sitting on the table next to it, you have this, which has a bunch of holes in it, and it makes lots of sound. What's that called? That's your speaker. Okay. So let's say that you are interacting with this radio, right? To make it go into transmit, you would ground this button. This is called the push to talk button. This converts it from receive into transmit mode. At that point, your voice goes into the microphone. It gets converted into electrical signals, which then go into the radio through amplifiers when you're transmitting. And we're going to draw just like a little transistor, and it goes out to an antenna. All right. When you switch it back into receive, you let go of the push to talk button. And instead of the transmit, what happens is that the signal path goes from the antenna through a different path and eventually gets amplified and detected and amplified and comes out through the speaker. So basically you have a very small signal that's on the RF path that is demodulated and turned into audio that comes out of the speaker. In order to interface this radio with a computer, you essentially have 3 lines. You have push to talk, you have a speaker, and a microphone. Okay, so here's my computer. So somehow the computer has to have a physical interface to hit the button and change the radio from receive to transmit. That's usually a relay or a transistor or something like that. Okay, you have the speaker of the radio. The speaker has to go into the microphone of the computer, and the speaker output of the computer has to go into the microphone input of the radio. Once you've done that, when you have the computer switch the radio from receive to transmit through the push to talk line, it basically looks at one of those 2 lines and sends the audio out to it. When you let go of it, the push to talk is no longer pressed, and the radio is now sending audio to the computer. What's cool about this is that now we can do all kinds of cool stuff with the computer. So let's say that we have a computer that is doing this, and that computer is connected to a radio, and the computer has a lot of processing power. And the computer also has a web server built in, and the computer also has something called a software-defined receiver built into it that is basically looking at just tons of RF data coming in at the same time and doing all the signal processing because you've got tons of excess processing power in your computer. And I don't know, can everyone hear that or no?
Yes.
Okay, so notice what we have here is we are looking at everything from 14.000 to 14.350. This is the entire 20-meter band in one picture. We're looking at the entire spectrum of the entire 20-meter band as received by a computer that's connected to a radio in Utah. This is a software-defined receiver. And what's nice about this is that the server that's running can let any number of different people use this at the same time. There might be, I don't know if there's, oh, here we go. Notice there were 216 users on this system. And we are on number 4, and right now number 4 has 27 users who are all able to independently use this data and tune this radio independently from each other. And this is free to use, don't need a license or anything. And what's cool is, in addition to being able to simply view what's happening,
you have to read about it. It's much, much better.
This allows us to also demodulate it and listen to what's going on. It also is a wonderful teaching tool.
South Carolina, QRZ. Was there a kilo station?
Okay, so what we're basically looking at is the spectrum. This is a frequency chart of everything that's happening at one time on the 20-meter band, all in one big picture. We can zoom in on portions of it, and we can listen to other things. Remember I talked about that thing called FT8 yesterday very briefly? This is FT8. Within that FT8 band right there, notice these goalposts over here on this yellow bar that I'm looking at. That was wide enough to listen to one single sideband signal. Right now, we're listening to about 50 FT8 signals. Those are that's basically digital computer-to-computer signals being transmitted. Now, it turns out, just looking at this, I think there's another thing going on today. Okay, this is another mode called FT4. Sounds kind of spooky, doesn't it?
Great soundtrack for a
isn't it? Isn't it though? So there's also, for instance, some Morse code going on somewhere down here. Okay, so what this is really good at doing is letting us visualize how much bandwidth a signal actually takes. So what we're going to do is go back up to the phone signals, and we're going to be on upper sideband, because by convention, upper sideband is used on everything above 10 megahertz. And we're going to look at an upper sideband signal like this one. Okay, so how wide is that signal? It goes from 14.238 to 14.241. 3 kilohertz wide. That's 3,000 hertz. That is how much bandwidth is required to transmit a single sideband signal, which we covered yesterday. An AM signal would basically be twice that size, but notice what you don't see. Where this line is at the very left edge of the yellow goalposts, you do not see a vertical bar or a stripe. That would be where the carrier signal is, and that takes up power and bandwidth, and it makes just a mess. Single sideband, we reinsert the carrier, and we only look at one sideband to make it work right. And it takes 3 kilohertz to fill up.
Kilo Echo 8 Papa Bravo Tango 591 Delta.
Okay, so now what we're going to take a look at is this other mode, again, called FT8. Well, notice we still have that same width goalpost, right? There are 50 signals in that same piece, that same area. How many signals were there in the single sideband? In that one set of goalposts?
Just one.
One. Right. This is when I say that this is a bandwidth efficient mode, it's digital. There's not a lot of data going back and forth, but each one takes up very, very little space, which makes it much more efficient. Unless your goal is to be transmitting, speaking at 200 words a minute. Bandwidth requires, or data, information requires bandwidth to send it. That's just a fundamental fact of information theory. The more information you send, the more bandwidth it takes. This is FT4. Each one of these is a very low bandwidth signal, but notice they take up less than 100 hertz each. So you can fit a lot of them in that same space. Do the same with Morse code. Let's go find one. What's the width of Morse code? There's a good one. How wide is that? That's considerably less than 100 hertz. The other thing is when we start getting signals that are really narrow, we can eliminate all of the extraneous stuff around, which increases our signal to noise ratio, which means we can pick up more of the signal that we actually care about. So that's the benefit of having narrow bandwidth signals, right? Because remember, we were listening to this. If there was another signal right next door, we could do this and eliminate the one that we don't want to hear. So that's called selectivity, the ability to select. Okay. Does that make sense to everyone? Web SDRs are fabulous tools that have only become really available in the last 10 years or so. And they're great for listening to what people are operating, how people are operating, what protocols are like, how to operate on a given frequency. I mean, these are just basically listening devices out there on the web. One of my favorite ones is in the Netherlands. It covers 30 megahertz at a time, the entire high frequency band, all on one screen. And you can also hear what's happening 9 hours travel away. So, okay, let's see, going back to this. Now, some of these things will probably make a lot more sense now. Okay, computer radio interface, receive audio, transmit keying, etc., etc. How do you operate FT8? FT8 is part of the WSJTX software package. Now, you've seen what FT8 actually looks and sounds like, right?
Jen had
Okay.
a question. Jen had a question about whether you could decode that DT8. Is that what that software does?
If you actually are running FT8, WSJTX, then yeah.
And would that be voice, or is it transmitting
No,
some
it's
other
all
kind of?
so it's a it's a very low speed communications mode. It's like 17 character messages. And they are typically there's the ability to do like free messages, but for the most part they're canned. The canned message is basically being this is me, here's your signal report. It's a very rudimentary system, but because there's so little information being sent and so much error correction, you can use it when signals are very, very, very poor. So, like, picture the amount of power coming down your antenna as 0.00000000001 watt. That's the amount of energy being captured by your antenna and being transferred to your radio. That is actually enough to be amplified into something that software, because of error correction algorithms, can actually detect. It's really quite amazing. That's why it's so popular for use on moon bounce. If we look at moon bounce, here's a moon bounce system. So we have our transmitter. This goes up to an amplifier, which might be 1,000 watts. This goes up to a dish, which might have 30 dB of gain. Okay, so everybody, what is 30 dB? How many times? How do you separate 30? This is a little bit of a follow on from yesterday.
Every 3 dB it doubles.
Yeah, or every 10 dB. It's easier to do it that way.
Oh yeah.
10 equals 10. So 30 dB is 10 times 10 times 10, which is
1,000.
1,000 times. So you have 1,000 watts going up into this. You have the equivalent of 1,000,000 watts or a megawatt aiming up at the moon. Well, that sounds like a lot, right? Okay, so let's compare this to a milliwatt. Okay, so let's say we have 1 watt. That's actually 30 dBm because it's 1,000 times bigger than a milliwatt. And that is amplified to 1,000 watts, which is then put through a 30 dB amp. So going from 1 watt to 1,000 watts is 30 dB. Okay, so what do we have? 30 dBm, 30 dB, and 30 dB. What's our signal? 90 dBm, 10 to the 9th times a milliwatt, which is right. We have 1,000,000 watts going up. Okay, that seems like a ton, right? But now we're going to look at the path from the Earth to the moon. And really, I should make this out of green, shouldn't I? Come on, anyone? Come on, that was funny.
Yeah.
Okay, the moon is green cheese. Okay, so we have our signal going up, bounces off of an object that's not really reflective. This signal path loss is negative 250 dB, or 10 to the minus 25th power. So like 0.25 zeros and a 1. That's how much, that's the proportion of signal that actually makes it back. It's ridiculous, right? That's insane. But that's how it works. So we now have the path loss of minus 250 dBm. On the other end, we have somebody with no, I don't want that. We have a signal coming down to somebody else's array, which has a whole bunch of Yagis, all phased and pointed in the same direction, which has a gain of, let's say, 22 dB. And there's a preamp up here, which has a gain of 10 dB, down to a receiver. Okay, so let's go through this path. We're going to go around the circle and see what we can do with this. So we start at plus 30, plus 30, plus 30. That gets us up into space. Minus 250. And then we come down, plus 22, plus 10. And what do we end up with? Who's got the math ready?
128 loss minus 128.
Minus 128 dBm. That, depending on the receiver, might actually quite likely will work. Actually, that's a little bit much, but it's entirely possible. So that's a good receiver. In other words, this path with those amounts of gain is actually enough to make that system work. Now, what have I not included in here that is actually a significant factor?
Loss in the cable.
Loss in the cable, yeah. So a system that could work could very easily be turned into a system that doesn't work because of what? Cable loss. cable losses. We're typically operating at very high frequencies, VHF, UHF. Cable loss can actually be quite significant. So we want to reduce those as much as possible. But this is the kind of cool stuff that FT8 is perfect for this, because the moon's not moving very fast, is it? I mean, it is, but not as far as we're concerned. It's basically up in the sky and it moves a little bit every second. But for the most part, it's basically stationary in a 2-minute period. But it's also really far away and it's not smooth and it's not really reflective. FT8 can pick up signals that are ridiculously weak, just barely above the noise. And that's why we do that. That's why weak signal modes are really good for this. Okay. All right, here we go. Next one, there's something called a ferrite choke. Remember we talked yesterday about a ferrite bar antenna that might be in your AM radio? You wind a wire around it a lot of times. That material called ferrite is actually a powdered iron usually. Iron is a ferromagnetic material, means that it reacts very strongly to magnetic fields. So what a ferrite choke does is a ferrite choke is typically something that looks like this, except we're going to make it brown because it's usually kind of brownish, like a donut. We take a cable and we do this with it. Okay, why would we do that? What exists around any wire that's carrying current?
Magnetic field.
Magnetic field. Okay, if we wind that around that ferrite, where is the magnetic field strongest?
In the center of
that coil that we made, right? And what did we wind it around?
Wire.
Iron powder baked into a donut. So that core is largely iron powder, which responds to magnetic fields. It becomes magnetized. So what ends up happening in that case is that our magnetic field, depending on the selection of materials, there also might be some manganese and some cobalt and other things thrown in there. By the choice of that, this has a frequency response. It does not respond typically much to DC. What it does is it responds to AC. The same way that a transformer works with AC. But in this particular case, what ends up happening is that this core tends to constrain the magnetic field and turn the energy into heat. The material is such that at certain frequencies, it turns the material into heat. So, does anybody know where you might find one of these things? There's probably one.
Computer monitor cord.
Computer monitor cord. Yeah. Why is that?
Interference.
Has anybody ever seen what happens if you get radio frequency into a monitor or into a computer?
They'll stop working.
Yes, and if you've ever had a computer lock up when you're transmitting, it's not cool. Or when you transmit, your monitor gets all wavy. Yeah. And that's because the power getting into it is essentially being polluted with RF energy. The choke chokes out that energy before it gets into your device. So why would any cable why would it actually pick up RF energy? So what we're going to do is we're going to draw our station. Here's our station. Here's my transmitter. Here's my transmitter. And here's my antenna, blah, 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 just like that. And here's my computer. And my computer is connected to my transmitter, typically by a USB cable. And this is connected into my wall or into my power supply. and my transmitter is connected to a power supply. Okay, what happens when I transmit? Where does the RF energy go?
Out.
Command.
It goes out. Yeah, where else?
Back along the USB.
Yeah, it goes this way too. It goes, you can't really control where it's going to go. Any piece of wire is what?
A conductor.
And what else?
An antenna.
Yes. Any piece of wire is an antenna, whether you want it to be or not. What is my USB cable?
Nice.
A shielded antenna.
Uh-huh. What is my power supply cord? It's an antenna. Every single piece of wire that's in is an antenna. If there's RF floating around, what will that antenna do?
Pick it up.
It'll pick it up. Yeah. And unfortunately, if it gets picked up by my power supply, and this is, let's say this is operating at 146 megahertz, my antenna, this power supply cable, is now picking up my power, picking up my RF and delivering it where?
To the computer.
Right to the computer, unless I do something to block it. So what I typically do is right here at the entrance to the computer, I would add a ferrite choke. On my USB cable, I add a ferrite choke. I might even add more than one. On my setup that I have right now, I have 5 ferrite chokes on my USB cable. Why do I have 5 ferrite chokes?
4 wasn't enough.
That's exactly right, because 4 didn't work. That's exactly right. I have a box of ferrites, and I kept adding them until the problem went away.
So, Scott,
Yeah.
are you talking about just doing like, I don't know if you can see that. This is an antenna.
Yep, those are clamp-ons, or those are snap-ons.
So, and this is what you're talking about, right?
Or you can that's a bead, or you can use like a donut and wrap it around multiple times.
Okay.
If the cable's flexible enough. The advantage to using a donut, if you have the space, is that the number of turns that you have up to a certain point, actually, it goes up, the performance of the choke goes up exponentially.
Oh, wow.
So if you have a ferrite core that looks like a donut and you can take a cable and wrap it around it 3 or 4 times, it actually works much, much better than 4 snap-ons. Okay, which of the following is preferred for bonding at RF? It is called a flat copper strap. Okay, so everybody, why is this the case? We sort of started to cover this yesterday. Radio frequency energy, or RF, likes to travel where on a conductor?
Around.
On the surface, right? It's called the skin effect. It likes to travel on the surface. So, which gives you more surface area? A round conductor or a conductor that's pounded flat with the same amount of material?
Flat.
Yep. So that's why we use flat strap. It has lower resistance to lower impedance to RF. Our goal is to provide as easy a path as we can. Okay, another one. Why should the negative power return of a mobile transceiver be connected to the battery? It does go to the battery, right? To the chassis ground at the battery. Why don't we go somewhere else? Cars are kind of a weird thing. So this is how a car is wired. This thing on the bottom is the frame of the car. We have our hot wires going to, let's say, our radio, or let's say our ECM, engine control module. We have another hot wire going out to ECM is engine control module. We have another one going to an AM FM. We have another one going to, let's say, a starter
After this, can
control.
you talk about the problem with the EVs and AM radio?
I don't know. I mean, I don't know that there really is that much in the way of problems. There shouldn't be. In fact, it should be cleaner, to be honest, because there's no ignition to worry about. I'd like to hear what you know, because I mean, from an engineering point, there really shouldn't be a problem. Okay, so
Go ahead,
so
Al.
wait, before we get there. Okay, so notice we have engine control module, AM, FM radio, et cetera, et cetera, et cetera. We take the negative and we connect that to the frame. And they take the negative there and connect it to the frame, take the negative and connect it to the frame, and take the negative and connect it to the frame. Okay, does this work? Yes, this is how your car is wired. Can anybody see a problem with adding something like this radio? So here's my 100-watt radio. We're going to run this off of the car battery, which is fine. What if I were to take the negative terminal wire and go down to here? What would be the problem with doing that? Right? It makes a complete circuit, does it not? I mean, I go from the battery out to the radio, down to ground, and back to negative terminal. That's a circuit, right? Everything's good. What do I not know?
Resistance.
I don't know what the system is like. I don't know what the resistance is like, because was that car ever designed to carry, in this particular case, 22 amps of current that I'm now using? Was
Probably
the
not.
car body designed to be a return path for 22 amps? I have no idea. Maybe. I don't know. Go ask the welding robots. Because that's where it's going. It's going through all the welds. And I don't particularly want to see that happen. Besides the fact that if there's a high resistance right here, let's say that this is 1 ohm, or let's say this is 0.1 ohms right here, and I get 2.2 volts of voltage drop suddenly, then all the lights on my car dim, because this is not at 0 volts anymore. This is now at 2 volts, so now I only have 10 volts, which will make my lights dim. It might also make my engine control module do something that I do not expect, like stall. So these are kind of things that we want to avoid. That's why you don't use the traditional way of wiring a car to wire your radio. Instead of doing that, you take the negative and you run it straight back to the battery. You run the wire straight back to the battery or straight back to the ground right near the battery, so that it's a very short connection. Again, 90% of problems are solved by
Grounds.
Ohm's law. Ohm's law, Ohm's law, Ohm's law. And ground in this case may not be ground, which is again an application of Ohm's law. Ohm's law comes down to, it solves 90% of problems. Okay, looking at battery capacity. How do you determine the length of time that a piece of equipment can be powered by a battery? Batteries are measured in either amp hours or watt hours. A watt hour is a watt for an hour. So a battery that is 50 watt hours can deliver 1 watt for 50 hours. Sometimes they're measured in ampere hours. So A 50 ampere hour battery can deliver 1 amp for 50 hours, or 2 amps for 25 hours, or 10 amps for 5 hours. It's a measure of the capacity of a battery, literally the amount of charge available to you. Okay, so we're starting to talk about EVs.
Yeah. So what I heard from Ford was it's EMI due to the high voltage batteries in the system.
Okay.
They're either doing it with shielding or active noise cancellation. But there were cars when they first came out that they weren't even giving AM radios to. And like the cabs in New York, they were getting really upset.
Because it would have made so much noise?
Yep. On
So,
two ways too.
Yeah. So that I hope that has been taken care of, to be honest. Those batteries are typically 400 to 440 volts DC.
Mhm.
And in order to switch to a different voltage, you will typically go through a DC to DC converter, which includes usually a little switching supply, and then an AC to DC converter. There's no reason those can't be made electrically quiet. It's just, shielding and essentially putting it inside a nice metal box and grounding everything.
They had to do that in with the new electric fire trucks that they were putting out because their Motorola radios had to be pretty clean. They're talking on P25 and the 800, 900 trunking. So that was a big issue when they first came out about 3 years ago. I haven't heard anybody yet because I've been out of the fire service.
All right. Any other questions before we go to operating controls? Nothing? Okay. Operating controls. Okay. So basically, there's a couple of operating controls that we will come up with multiple times. We are on now page 76. And the answer to a lot of these things is going to be something that's quite repetitive. Okay, so we're going to go back to here. Can everybody hear that okay? Okay, sounds like we're listening inside a hollow metal tube. Okay, so right here, this is bandwidth. This is the bandwidth control on a radio. These are receive filters. On older radios, those would actually be done by crystals or by capacitors and inductors. This is being done digitally through software. They effectively do the same thing. So by changing the receive bandwidth, that allows me to be more or less selective. I can also do things to increase the sensitivity of a radio. Sensitivity is being able to listen to really, really weak sounds. I could switch in another amplifier, so long as it doesn't generate a lot of noise. It will hopefully be able to make a small signal bigger. Again, it does actually create some noise at the same time. It doesn't know what the difference is between noise and not noise. Again, this is what filtering does. So it's nice on a radio to have multiple different filtered choices based on the mode that you're listening to. There's no reason, honestly, that I need to listen to everybody if I'm only listening to one person at a time. If I'm listening to this, that's 50 different signals. I may actually decide that I only want to try to listen to one of them. That's some pretty good selectivity, right? Now, if I tried to do that with a voice signal, what do you think it would sound like? We're going to try it. What do you think it's going to sound like?
A voice?
Distorted.
Here we go. Let's go find one. Nice wide one. Okay, here we go. That's a. Okay, so this is about 2.5 kilohertz. That's enough to still have a narrow filter. So we can filter that down to about 2.5 kilohertz. But look what happens if I keep going down. So why can't we understand it?
Not enough bandwidth.
Yeah, we're that whole bandwidth contains the information that is required to make up an intelligible voice. And we're only getting a little bit of it. I mean, I could pick another little section, like up here. We're missing lots of information there. That whole bandwidth is required to hear the whole thing.
So basically, we're only hearing parts of the
You're
voice.
only hearing a little bit of the voice, and it's not enough to, I mean, like if we were to do this, for instance, there's enough left. This is about as narrow as you'd want to go. Because you can still make it up by listening to that. But if you go any narrower than that, you lose intelligibility. Okay, other things we can do. Essentially, there's something called a variable frequency oscillator, which is a VFO, that allows us to tune our radio. On this particular thing, it's a slider, right? So there's our changing our bandwidth. By doing this, notice that little bar on the left-hand side, 14.244, 14.243, 14.242. Essentially, we're looking at and listening to a different frequency by doing that. That allows us to tune our radio on an old school piece of equipment. That would actually be a dial knob, like turning the knob, allowing us to change it and go and listen. Let's see what this is. Okay. Other things, something called squelch. All right, so what did squelch do?
Cancel out some of the noise.
Yep, it mutes the receiver when there's nothing of any interest to listen to. That's called squelch. See, and I can also mute it. That's just basically muting it altogether. Okay, so that's squelch. So let's say that I have 3 different stations that I'm listening to. And okay, so here's one. I'm going to turn it on. And I find it to be of particular interest, right? But whoever it is seems to be kind of busy. So I think I'm going to come back to it later and go over here. Ooh, there's one. Okay, so does everybody remember what the frequency was of that other station that I was listening to?
No.
I don't really either. Okay, so when you have a piece of equipment, you can store frequencies in memory, either temporary or permanent memories. That allows you to be able to recall what those were. So I think it was over here. So this is honestly probably has the ability to store memories. I don't know for sure, but any other, like for instance, a typical handheld radio will have 1,000 memories that you can program and store and go to for quick recall.
In a handheld?
Just in a handheld, typically 1,000 memories. Yeah.
Okay.
A handheld with a few memories these days is 200. And they can be saved in frequency banks and all kinds of different configurations. Okay. FM transceiver. FM is frequency modulation. What does it do? The scanning function. The scanning function allows you, we're on page 77, by the way, allows you to scan through a bunch of different channels in order. Changes through a bunch of different frequencies very rapidly. Okay, we covered squelch. Okay, so what do you notice about that whole squelch function that we just did? So we're going to go and listen to this, and I'm going to turn the squelch on. Is it possible for me to set the squelch level so that I can't even hear a signal that is there?
Should be, yeah.
Yeah. Okay. So basically, like this one is just on the borderline. So if you know that there's a weak signal nearby and you want to listen to it, what would you do with your squelch?
Or
All the way off, or as close to off as you can. And that would basically just open up the receiver so you can listen to it without being squelched. All right. And we do actually use that frequently. So
used to use it a lot with scanners too.
exactly, because there's some things you just don't need to hear.
Is that notch like discrimination?
Okay, so a notch filter, where was that? Oh, the
On
notch. Okay. So what a notch filter does, all right, this is a good time to talk about filtering. So I'm going to draw some filters. Okay, remember we drew components that look like this?
Mhm.
All right, that's a variable capacitor and a variable inductor. Those are tunable circuits. In digital, we can do filtering that's based on computer program. In the physical world, if we're doing analog, it's based on those two types of components. By doing this and putting it in series with this, for instance, and having those two be variable, we can change it so that we get a frequency, a resonant frequency that is selected by those two devices, which is 1 over 2 pi square root of LC. There's our C and there's our L. When that happens, these cancel each other out and it becomes a short circuit. This kind of filter has a pass band that looks like this. And that is known as a bandpass filter. If we were to take these and draw this a different way, and make them look like this, at our resonant frequency, it would be inverted. That would be called a notch filter.
So a notch is an inverse of a bandpass?
Yep. That's what it is. And we could just basically take a single capacitor or inductor, and given what you may have remembered from yesterday, let's say that I have a circuit that looks like this. I better pick a different color. I want pink. There we go. Okay. I have a mix of AC and DC going this way. What's going to happen to the AC when it gets to that capacitor?
Gonna go back the other way.
It's gonna
AC is
charge
going to
it.
go that way. Yep. AC is going to go to ground. So if the AC goes to ground, what is left going that way?
DC.
DC. What is the frequency of DC?
0.
0. And actually, I can enhance this by putting an inductor right there, which blocks any additional AC. And my frequency response looks like this.
Wow.
And that's called a low pass. That's called a low pass filter. I can reverse those things and change the color. I'm going to pick blue. And now I'm going to erase that and erase that. I still have AC and DC, except now that we're dealing with the blue circuit. And I have an inductor going this way and a capacitor over here. So I have AC and DC going this way. An inductor is just a piece of wire, so the DC goes this way. What's left going this way? AC goes right through the capacitor. So what passes through the circuit? The AC.
AC.
And my circuit response looks like this. That is called a high pass filter. And by combining multiple things together, you can build all kinds of different shapes. If you have a stereo system, if you have a speaker that has, let's say, 3 different speakers, a tweeter, a mid-range, and a woofer, everybody remember those?
Oh yeah.
Which one do you think you would use for what? Tweeter is what? What kind of pitch? What kind of sounds?
Frequencies.
High frequency. You'd use a high pass filter. How about for the woofer?
Low pass.
Okay, and for the band pass, which is your mid ranges, for the mid range speaker, you'd use a band pass filter. Which is why these two devices, capacitors and inductors, are so very cool because their frequency, they have the ability to they have the ability to respond differently to different frequencies. We can do all kinds of cool frequency-based things with them. And I guess I should draw that this is frequency and this is amplitude. And that starts at 0 and goes to infinity. All that just from capacitors and inductors. So much tuned circuitry. And it's amazing when you say, when you start looking at like, okay, well, we've got noise coming out of the switching circuit on an electric vehicle, right? How do you eliminate that?
Shielding.
Shielding and
A filter.
filters. So the same kind of thing, the same kind of answer is going to come up over and over and over. A ferrite choke that you put on your cable for your computer. Who had that handy? The ferrite core. Can you hold that up again?
Let me see. Where am I? There we go.
There we go. All right. What kind of device is that? What would that be considered?
A filter.
What kind of filter?
A bandpass.
Well,
Bands.
what do we want going through, AC or DC?
DC.
And blocking all the AC. So that would be a low pass filter.
Okay.
It's just basically when you look at the world in terms of AC and DC, filters are the way to separate them. If you're building a power supply and you have a transformer that's making AC and you convert it into that choppy looking DC and you use a capacitor to smooth it out, what kind of filter would that be? You're trying to get rid of all the hum, all the stuff that bounces up and down. Stuff that bounces up and down is AC or DC?
AC.
AC. A capacitor being used in a power supply is what kind of filter?
Oh,
Low
A
pass.
low pass filter. Yep. When you do this, here's your diode, and you do this, and you have an AC source over here, and you end up with DC coming out over here. The capacitor is being used as a low pass filter because it's taking the AC components and sending them off to ground so that they don't show up on the outlet, on the out feed.
Guys, you
Awesome.
have a question here from Jen and Zane in the comment in the chat.
Yep. I don't see it yet. Oh, there we go. Okay. How come I can make a circuit that transmits on AM on a station with full static, yet hear what my circuit does noise-wise as a microphone without needing a license using the easy circuit builder? Okay, because below a certain power level, nobody cares. How's that for an answer? Does that make sense?
What's that power level usually?
Oh, that something like that, probably 20 milliwatts. It's going to be a very, very low power transmitter. Anything over anything above, like probably 100 milliwatts has probably got to be licensed. So when they design those, in the circuit books, that becomes a transmitter with a range of 25 feet. So nobody's going to care at that point. Okay. Let's see. We did scanning. We didn't do repeater offset. Okay. And then we're going to take a break in a couple of minutes. I think we're almost at the end of this section. So our goal is to get to the end of that section. Okay. Okay, repeater offset. A repeater is a device that hears something that's happening on one frequency and automatically shifts it and retransmits it to another, usually through the use of a controller. So if I were to do this, a repeater, let's say that I have my handheld radio over here. Here's my hand. And it is listening on 146.72 megahertz. When I transmit, it will shift the frequency that I'm transmitting on by negative 600 kilohertz, which is 0.6 megahertz. Same thing, just two different ways of saying it, which means that it will now be transmitting on 146.12 megahertz. That is known as the offset. The reason it does that is because somewhere up on a hilltop, there's a box with a receiver connected to an antenna that is listening on 146.12, taking the audio that's received, putting it into a controller, sending it to a transmitter that is simultaneously transmitting it on 146.72 megahertz, which is then going out to me as well as to the rest of the world. Everybody who is listening on that frequency in that range could hear me. What's nice about that is that I am now transmitting as though I am on top of that mountaintop. That's why repeaters are so helpful. The difference between the receive and the transmit frequency on the 2-meter band is 600 kilohertz. Depending on whether or not it's below 147 megahertz, it's a positive offset, and below that, it's a negative offset. Okay, so that's how repeaters work. On the 70 centimeter band, it works similarly, except that the offset is plus or minus 5 megahertz. So if I'm on a repeater that's at 441.600, I will be at 446.600. It's a shift of 5 megahertz. And those, for each repeater, whether or not it's a plus or a minus offset, those are published. So this brings to mind another interesting question, which is if I have two boxes, this one is receiving on 146.12, and this one is simultaneously transmitting on 146.72. Those are very close in frequency to each other. What makes this even more challenging is that sometimes these can actually be using the same antenna. Well, if that were the case and there was nothing protecting one from the other, wouldn't the signal being transmitted also go back into this receiver?
Yeah.
What do you think we have to put right here?
Duplexer.
The filter.
Filters. And in fact, when you said a duplexer, that is a duplexer. It's a receiver duplexer, which is usually a very, 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 very tightly filtered circuit with attenuation of 110 dB from receive to transmit. What is 110 dB?
10 times or 1 times 10 to the 11.
10, yeah. Well, it's actually negative.
Right.
That's how much of the signal that's being transmitted gets back into the receiver through that filter. Those are very, very, very tightly built filters, very tightly tuned. And they're also quite expensive because you can't usually just make those out of things like this. They are not tight enough to do that. So what you end up doing is you end up either building or buying something that looks like this. See this hollow tube up here? That is a filter. That is a cavity filter. You put 6 of them together and it looks like that. And notice that at the top of each one of them is a big tuning screw. You basically have a device called a spectrum analyzer. And what you do is you look at the input and the output and you put a signal into the output and you see how much of the output, how much comes out to the output. And if it's too much, then you adjust the screw up and down and change the length of the filter.
Do they get warm?
They do. But they're also big and made of aluminum, so whatever. You don't care so much at that point. But yeah, anything that's attenuated ends up as heat. So, okay. Let's see. Next thing. So that's repeaters and filters and a digital mode hotspot. Okay, a hotspot is a device by which a user of a radio can connect to the internet using a digital radio.
D-Star.
D-Star, or sometimes just there's something called Brandmeister, there's DMR, there's a whole bunch of different things.
I have D-Star on my Kenwood.
I've never used D-Star. I've used DMR. And Yaesu makes another one called Fusion. Basically, what it is if everybody remembers the Betamax versus VHS thing, two similar things that are different and don't talk to each other that do the same thing. So they each think that theirs is better. So a talk group on a digital repeater. A digital repeater is different from analog because you have two signals that are just basically converted voice that's been converted into ones and zeros. On the other end, it gets converted back into voice. What's nice about it is that ones and zeros, what is a 0.8? If I get instead of a 1 and a 0, if I get a value of 0.8, what does that mean? Is that a 1 or a 0? What do you think? Which would you pick?
1.
Yeah. If I got a 0.2, what would you pick?
0.
Yeah. So what that means is that the digital modes, especially because of that and because of error correction, are largely immune to noise and interference. If I got noise on an analog signal, that's what you get. You can't fix it. Digital, you can. So a talk group is a talk group on a repeater. It determines who you're going to be talking to and which of the two channels you're going to be using. A code plug, I don't know why it's called code plug, but it's for DMR, which is digital mobile radio. A code plug contains all of the configuration stuff that you would ever want to talk to on your radio. No, I don't know why it's called a code plug. It's basically a configuration. How is a specific group of stations selected on a digital transceiver? You enter the group's identification code. What's interesting about this is that because it's digital and it can be switched over the internet, if you have a repeater that's connected to the internet, You can get a packet of information which contains your voice that says, I am destined for the internet. It gets sent to the internet if the internet is up and functioning, and gets sent to another repeater somewhere else that could be 6,000 miles away. At that point, it gets there, it gets turned back into audio and put out over the radio. What's cool about that? You're using a handheld radio in one place, somebody else is using a handheld radio in another place. They might not even be using a repeater at all. They might just have a hotspot. And two people on handheld radios can be talking 6,000 miles apart using the internet as a bridge. Entering the group's ID code. There's also something called a color code on a DMR repeater. It's literally just color. Don't know why they call it that. It just started that way. D-Star handheld, you probably had to put your call sign on it, because when you transmit, there's a digital signature that's placed on it, which says this is the transmitting station. On someone else's screen, when they hear you, it'll actually pop up with your name and call sign on their radio.
Yeah, D-Star won't allow you to transmit unless you have a valid call sign and you register it.
Yep. Yeah, DMR is the same way. Advantage of having multiple receive bandwidth choices. We did that. You can filter things out. For single sideband, the tightest you want to go is 2400 hertz, which is 2.4 kilohertz. If somebody is a little bit off frequency, you would use something called the RIT, which is receiver incremental tuning. Yaesu, another manufacturer, calls that the clarifier. They're the same thing. PTT means push to talk. It switches a radio into transmit. All right. A transceiver is a device that combines a receiver and a transmitter. A transverter is a device that combines a transmitter and a converter. It converts it from one frequency band to another. The reason being that why these exist, there are certain frequency bands for which there is no commercial equipment at all. We have access to those frequencies. If you build a converting device, which essentially takes a frequency from one that you do have equipment for, it will put out a signal on the other band. A device that increases the output power by making a bigger copy of a signal is called a power amplifier. This one we covered a little bit yesterday. You remember that I drew those curves for transistors where you have the linear section right in the middle, which is a nice straight line, and the flat areas on both ends. If you tried to amplify your voice using the flat ends, it would sound all distorted. So if you're doing single sideband, which is an analog voice signal, basically, you would want it to be linear. So you want that straight line. So that switches the mode of the amplifier. It switches the bias point of the transistor that you're using. Okay, I like to do this one. Sensitivity. All right, so everybody, I want you to unmute yourselves. All right, so sensitivity is, let's see, how about Doris? I want you to whisper something.
Sensitivity.
Okay, I couldn't make out what you said, but did anybody make out what Doris said?
Sensitivity.
Yeah.
Okay, good. Okay, so your ears are potentially more sensitive than mine. All right, now on the count of three, everybody say your name. 1, 2, 3.
John.
Okay, if you could pick out one of them, that's called selectivity. If everybody had a really narrow signal, then you could also filter for that. So you can increase selectivity by increasing your filtering, by working on your filtering. An RF preamplifier is installed between the antenna and the receiver. Ideally, a preamplifier is going to be installed as close to the antenna as possible. And why is that? Because if you lost a bunch of the signal that you're trying to listen to in the cable between the antenna and the receiver, can you amplify something that isn't there in the first place? If it's already gone, you can't amplify it. So this is why cable TV systems will install line amplifiers close to the, not to your cable box, but at the other end of the cable if there's signal loss. So right near the little green box in the street. A mixer is a device that converts a signal from one frequency to another. A mixer is at the heart of a transverter. A circuit that generates a signal at a specific frequency is called an oscillator. In the past, and I guess you could say in the past, but we still use them today. This could be used as the core of an oscillator. Because if I have this being tunable, if I can tune it and I can tune this, can I generate a frequency? Can I generate a resonant frequency using these? Yes, I can. If I can generate a resonant frequency and amplify that frequency, I can create a frequency out of nothing using a transistor or a vacuum tube. I could also use something that looks like this. Does anyone know what that schematic symbol is? Now, does anyone know what that is?
Nope.
That's a crystal.
Wow.
That is the basis for a crystal oscillator. And believe it or not, those are still used today for very, very accurate frequency generation. A quartz crystal that has been cut to size and shape inside a metal box. Those are still used today a lot.
I can remember using those on my Radio Shack CB.
Yep.
Yeah.
The other thing that you can do to make a frequency is that you can generate it using a microprocessor, believe it or not. The way we do it is called frequency synthesis. If we simulate a step-by-step picture of a sine wave and the steps are small enough, and then we filter it, we can actually generate a very clean sine wave using a lookup table and a computer. The process of combining speech with an RF carrier signal is known as modulation. Okay, I'm just going to, you know what? I'm just going to go through this section and then we're going to take a break. Does anyone really need a break right now?
No.
Nope.
I'm good.
Oh,
I do.
do you? All
Yeah.
right. You know what? Let's take a 5-minute break.
Cool. Thank you.
All right. All right, here to answer questions before we get going again. If anyone has any questions or wants to talk about anything, this is a good time. Not to put y'all on the spot or anything. Nothing? Nada? I'm okay with that. All right, so before we get started, I'm gonna pose a question and let's see how everybody is coming up with learning this stuff. So I'm gonna draw a bandpass filter. All right, so this is zero frequency and this is infinity. We measure the bandwidth and the cutoff frequencies of a bandpass filter by measuring the point at which we call this a 0 dB, 3 dB. We call this the bandwidth right here. And in fact, we call it the 3 dB bandwidth. Why do we call it 3 dB? Why is that a convenient number? What does 3 dB mean?
Where it's at half power.
That's right. This is the half power right there. So we end up looking for 3 dB because it's half the power. And that's just a convenient number. Easy to calculate, right? So we call that the half power or 3 dB bandwidth. If we're looking at antennas, so here's an antenna pattern, right? So we're going to have a grid that looks like this. And these concentric circles, this one represents, for this particular antenna, let's say that our antenna looks like this. What would that antenna be called? It has a name. You remember what it was? What was it?
Jaeger.
That's a
Yagi.
Yagi. Yep.
Doggy.
Or really, it's actually Yagi Uda. But
Yagi.
Uda didn't get the credit that he should have, so it's just called a Yagi. They were working together, but okay. So if I were to draw the beam width, the antenna pattern for this antenna, it might look like this. All right. So if I mark this value out here as the 0 dB line for this antenna, how do you think we measure the beam width of the antenna?
I'm guessing.
Half PowerPoint.
Half power point. 3 dB. We measure the beam width based on the 3 dB markers. This 3 dB shows up all over the place. It's used literally everywhere. And that's called the half power point. Yep. You will see that referenced everywhere. If in this 3 dB shows up all over the place. Okay, moving right along. Symptoms, cures, causes, and of common transmitter and receiver problems. Well, okay. What do you think the most significant problem that we have is with regard to transmitters? Interference. Okay. So either we're being interfered with or we're interfering with someone else.
Something else.
So what do you think the most common way to eliminate that problem is? Starts with the letter F.
Filter.
Filters. Yes. Filtering, filtering. Right? That is the answer to almost every question regarding interference. Filtering in one form or another. Basically, removing a signal from where it shouldn't be. That's what filtering is for. All right, so fundamental overload, that means that there's basically just too much signal from a nearby transmitter. That was what used to happen when I was living in Maryland, and there was a all-comedy station on 1050 AM called WJOK, which was less than a mile from my house at 50,000 watts. Any radio I turned on, no matter where I had it tuned, I would hear WJOK in the background. That's called fundamental overload.
I get that out here in the high desert.
Yeah, whatever station is, I mean, you're just going to hear it because it's just there.
Also, the old radio stations that used to use for an STL link, when they used to use microwave, that bleeds too.
Does it? Okay.
Yeah, they used to bleed in New York. They used to have issues on some of the like WOR, the old stations.
Okay, well, while we're talking about that, let's just bring this up. Okay, so here is another one of the reasons why we go through the process of licensing. We're allowed to build our own transmitters, right? That's one of the things that we can do. So we have frequency of 0 to infinity. And here's our amplitude. And so we have our 0 dB mark. This is our intended mark. So we design a transmitter that operates on this particular frequency or within this certain frequency band. When we are transmitting a signal that is 0 dB, there are rules that say that all other frequencies that are generated have to be suppressed. What does suppressed mean? Pushed down.
Pushed
right?
down. Yeah.
Okay. Depending on the frequency you're on, that could be 40 dB. It could be minus 50 dB. It could be minus 60 dB, depending on the frequency that you're operating on. And these are going to be like 10, 20, 30, 40, 50, 60. You might find, so this is an idealized picture of what your transmitter is doing, right? There is no transmitter in the world that looks like that, for which the power output looks like that. It just doesn't happen. What ends up happening is you end up with something that looks like this. So what you end up with is spurious emissions, which are transmitted signals that don't really have any real relationship to the desired frequency. And there are some spurious emissions. You might also have a direct multiple like this one. That would be a harmonic because it's a multiple of this frequency up here. So this would be, let's say, 10 megahertz. This one would be like 20 megahertz. You would see a harmonic there. So you'd see multiple different things that are transmitted. And why is that true? Because there is no such thing as a perfect amplifier. There is no such, amplifiers have capacitance. Amplifiers will sometimes operate at frequencies you never expected. So what you'll end up with is potentially some out-of-band transmissions. So who are those out-of-band transmissions going to interfere with?
Other people.
Who knows? Yeah, it could be
Yeah,
anyone.
never know.
It could be anyone, right? So there are rules regarding spectral purity when you're building a transmitter that says that all your signals within a certain band, whatever that band happens to be where you're operating, have to be a certain number of decibels down from the fundamental frequency. So let's say that I have tested my transmitter and found that it is in compliance, right? So here's the 60 dB mark from the fundamental. It is legal. It's perfectly fine. Is it free of interference? Yes or no?
Oh,
No.
No, because you
Those
got
signals
stereo.
still exist, right? So let's say that I'm transmitting at 1 watt up here. Let's say that's 1 watt. How big is this signal right here? It's 60 dB underneath. What is 60 dB?
1 times 10 to the minus, or minus
10
1
to the
times 10
minus
to the
6,
6th.
right? Which means that this is 0.000001 watts or 1 microwatt. Going through an antenna, can that still be interfering? Can that still interfere with someone? Absolutely.
Yes.
Yeah. I mean, it's perfectly legal. So let's say that there's another device out there, like a microwave oven or a television, that is meeting similar rules and it's operating legally. Can it possibly still interfere with you?
Yes.
Absolutely, because it's impossible to knock everything down all the time.
So if you're close enough to a boundary, you could unintentionally be transmitting on frequencies you're not allowed to.
Yeah, except that, I mean, you're still legal, but let's say that you live right next to an airport and your transmitter puts out a microwatt on an aircraft, air traffic control frequency.
Not good.
That would be, yeah. I mean, you'd still be transmitting legally, but you would probably need to do something, right? If you don't live right next to the airport, nobody will ever know. No one will ever care. But if you live right next to the airport, it might make a difference. So there are times when things actually do make a difference. There are also other devices. Amateur radio is covered under Part 97 of the FCC rules. Everything that is an unintentional radiator, like for instance, this computer power supply. If you look very carefully at what this computer power supply says, somewhere on here it says FCC. And it will also say complies somewhere with Part 15. Part 15 is unlicensed, unintentional radiators. In other words, they can make RF energy. They also have to accept RF energy, even if it messes them up. Now, it doesn't mean that you should do that, but if I have a licensed transmitter and it's causing this computer to lock up, who's at fault?
You are.
No, they are.
No.
The Part 15 device must accept all interference from a licensed service. So it doesn't mean that you shouldn't try to do something, but it means that if your equipment is operating properly, it is not your fault. Again, it doesn't mean you shouldn't try to help, but it means it's not your fault. Okay, so the first thing you do, if your neighbor says that your transmissions are interfering with their TV, well, you check your own equipment, check your own TV when you do the same thing. The assumption is that maybe there's something wrong in their equipment. It was built to Part 15, and maybe it wasn't built very well. Maybe there was a bad capacitor that, a bad batch of capacitors that showed up in 1,000 TVs that were made. And unless there's a ham transmitter right next door, it doesn't have a problem. Therefore, the other 999 are just fine, right? You never know. If you have non-fiber optic cable TV, which is cable over coaxial cable, TV, cable TV over true coaxial cable. If the connectors loosen up, they start to leak. They leak signals out. They also leak signals in, like the ones that you're transmitting. AM/FM receivers can receive signals unintentionally if this is called basically fundamental overload. The signals are just too strong and they're not built well enough to reject signals outside the band. So what do? If you can do it, you put start with the letter F, filter on it, and block those frequencies that are getting in. How does fundamental overload work? Fundamental overload, again, is just basically a receiver is not built well enough to reject the signals. Again, like when I was driving past WJOK, it didn't matter where I was, I could hear it. Because if they're transmitting with 10,000 watts and their signal outside the band is 60 dB down from that means that we're still getting 10 microwatts, or sorry, 10 milliwatts, and I'm driving right past their tower. I'm still going to hear it, even on frequencies that it's not supposed to be. And what's the solution?
Filter.
Filter, 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 filter. Yep. Notice which of the following can reduce overload of a transceiver by a nearby commercial FM station? There's that word again. Filter, 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 filter. It shows up everywhere. What do you do if something in your neighbor's home is causing harmful interference to your amateur station? This is my favorite thing, one of my favorite things that has ever happened since I've had my license. And so here's my house over here, and it's it doesn't exactly look like the house that I live in, but here's my house, and I noticed that on 3.522 megahertz, which is in the 80 meter amateur band, and it's in the Morse code part of the band, which is CW, I was receiving from somewhere a signal which was FM. And it was clearly a woman talking. And there was a dial tone some of the time.
The old cordless phone?
Well, you would think so, except that most of them are smart enough to not build a cordless phone that operates on 3.522 megahertz because, for one thing, that's a very low frequency. That takes a big antenna to work.
And a lot of power.
And no, not a lot of power, but still, you would typically never use a frequency that low just because the antenna has to be so big. So we're obviously talking something else, but now we're also talking something that could be anywhere because, I mean, that could be miles from my house. And I grabbed a receiver that was battery powered and just started driving around the neighborhood. And after about a year and a half of this, I got to a place where it sounded like it was getting stronger. And it turned out that there was nothing there. There are a lot of windy streets in the neighborhood. And eventually I found a house that when I walked in front of it, it was like super, super loud. I had no idea who lived there, but I said, that's got to be where it's coming from. And I could hear two people having a conversation, like a private conversation over the phone. I asked my wife and I said, do you know who lives at this address? And she did. And she called them on the phone and said, my husband thinks that you're broadcasting your phone conversations all over the neighborhood. And I went in and said, yep, I can hear you both. And she said, oh, would you mind sending him over? Well, it turns out that in their house, they had the jack coming in to the house, and they had another phone jack over here, but then they had additional rooms in the house that didn't have phone jacks where they wanted to have telephones. So they bought this thing. Well, it wasn't. It was actually, it plugged into your phone, would connect to something that plugged into the wall and used your house wiring to give you additional phone jacks in different places.
Mm-hmm.
And it operated at 3.522 megahertz.
Nice.
Because for very low power stuff, it's okay. No one's going to complain, except for the fact that in this particular case, what is all of that house wiring?
Antenna.
That's an antenna. So basically, whenever she was on the phone, her entire house wiring was broadcasting on 3.522 megahertz FM, her conversations all over the neighborhood.
This was really often used by Dish Network and DirecTV to use for on-demand, to order on demand.
This was similar, but it was even older than that. This was from like from the late 90s. And she said, "Would you like to come over and take it from me? Because I don't want this in my house." And I have a friend who's our radio frequency interference guy for the state of Oregon, and I gave it to him. He said, "Oh, thank you. I've been looking for one of these."
You could have collected some good blackmail material.
Yeah, exactly. Well, just, as an example of if you ever find one of these, unplug it immediately. So, who's at fault? Technically, her stuff was working legally, but it was interfering with a licensed service, which made it not legal. And she really didn't want to be doing it in the first place.
That's why they're punting off those for antennas for homes, for like just instead of using a regular antenna, they use the whole home's electrical system.
Well, that was unintentional. It was using the wiring to carry the signal. But but the wiring was all an unintentional radiator, which was sending signals out into space.
What specifically are you talking about finding and unplugging? Like what device specifically was it that was causing the issue?
I can't remember what it was called, but it was actually
Magic Jack.
I think it was a Magic Jack.
Oh yeah.
Essentially, what it did is it modulated an RF signal and ran it through a capacitor and put it onto the power lines, and used the power lines to carry the signal around the house, so that you could basically plug your Magic Jack in and separate AC power from the modulated RF signal and use that into your phone.
And all it was doing was sending tip and ring.
That I don't know. I mean, it
had to, because if you're plugging into a telephone, it had to have had minus 48 volts.
Oh yeah, true. Well, no, but except it wasn't using the phone line.
No, but
it was using the audio.
It was, but when it came out of the Magic Jack, it came on a 2-wire.
Oh, that's true. Yeah, so it was basically simulating a telephone line.
Yeah.
Yep, that was one of the more interesting ones that I've ever had. She was so happy to get rid of that. Okay, if your signal is unintelligible or distorted, and you're using an FM transmitter like a handheld, you could be off frequency, your batteries could be low, you could be in a bad spot. FM is very unforgiving when it comes to weak signals. They tend to get very distorted very quickly, a lot of noise. When they're good, they're great. When they're bad, they start to go really fast. RF feedback, which is basically RF getting into the audio circuits, ends up with garbled, distorted, or unintelligible voice. Most handheld radios do not have a mic gain control to turn up the microphone. And so mic gain is controlled by taking the radio and moving it further and closer away, further away and closer to your mouth. Okay, test instruments and soldering. A multimeter is a device that measures voltage and resistance. What would you use to measure electric potential? That is a voltage, electric potential. So we use a voltmeter for that. How do you use a meter to measure voltage? You measure it across the device, essentially in parallel. How can you damage a multimeter? Well, if you use the resistance setting, the way an ohm meter works, which is for resistance, is, let's say I have a resistor here. Okay, what's Ohm's law, everybody?
Equals IR.
Okay, so if I have a battery in my meter and it goes like this, this produces a current. I know what my voltage is because I built the meter. Now, if I can measure the current using an ammeter, which is built into my circuit, and I know the voltage and I know the current, I can calculate the resistance. This is what an ohm meter does. This is also why, if we're using an ohm meter, you cannot use it to test a resistor that is in a circuit, because if, let's say, there's another battery in this circuit and it's doing something and going through a capacitor or something like that, and then another resistor, you're actually measuring a combination of things. I mean, your meter is now part of that overall circuit, so you're going to get answers that don't make any sense. So in order to measure the resistance of a device, it needs to be removed from the circuit. You are basically providing your own circuit to test it.
Scott, not to show my age, but if you remember when we had rabbit ears, they were 300 ohm.
Yeah.
And you would have to take a converter to go to 75 ohm to coax on the newer sets.
That is a 4-to-1 transformer. That is a 4-to-1 impedance matching transformer. And they still have those. Although I don't know if anybody has rabbit ears anymore.
No, because all the analog signals are gone.
Yeah, right. Okay. All right, so that's an ohm meter. Let's see, getting back to the meter stuff. Okay, so does anybody have a Harbor Freight nearby?
Yes.
Okay.
Just
Harbor
down over.
Harbor Freight has its place, doesn't it?
Yeah.
Yeah.
I like Harbor Freight for some things.
Radio Shack was better.
Yeah, but Radio Shack was specifically for electrical stuff. So does anybody have one of these?
Yep.
No, I have one
do.
too. You know why? Why do you have one?
We were different reasons. We were trying to find some problems with lawnmowers and also in our house.
Okay, but why? In other words, my question is, why do you have one of those, which is what it is, versus one of these? Yes, I was actually going to bring up a fluke, and here's the fluke.
Right.
Okay. Why? Yes, that's a big thing. Yes, I have one of these. I have one of these for work, and
My husband does.
I have one of those too.
And what is the big difference between these? Well, it's kind of slow to load today.
$550.
That's right. This is $6.99. But to be honest, I got mine for free with a coupon, right? And you can't beat free. This, on the other hand, was about the price now is about $600. And notice it says it'll measure 1,000 volts. And let's see. Oh, come on.
Never know how to answer that.
This one technically will measure, if you look at this, the stuff, it'll go up to 250 volts. Yeah, it'll do 250 volts. So they say. So which would you want to use to measure a 24 volt or 12 volt circuit? I think I'd be fine with this one.
Yeah.
Right? I do it all the time. I have one in my bag. I would even measure 120 volts with it, coming out of the wall.
Can you send a link to that?
But I would be really, really careful. I certainly would not use it to measure 480 volts like I do at work. I get all suited up. And however, for this, notice this is 1,000 volts max AC, category 3, category 4. This has all kinds of stuff associated with it. This one could suddenly blow up unexpectedly to high voltage. These are probably not the best probes in the world. This one, the probes that you get with it are all, rated for use at 1,000 volts. And I tend to trust it. I'm certainly paying 100 times as much for the meter.
Yeah.
So Anyway, I guess the point of all that is that not all meters, even though they are both multimeters and they measure the same thing, are created equally. So it is
That's why I love.
important.
That's why I love my Simpson.
Oh, there you go. Is it a Simpson 260?
Yeah, I inherited both of them from my father when he passed away. He was a fine collector of the high end stuff.
I have one of those somewhere. Okay, so to damage a multimeter, you can, if you try to measure it using the wrong setting. Has anyone ever blown up the ammeter fuse inside your multimeter? I've done that.
Oops.
Yeah, I've done that.
How did I bump?
When measuring high voltages, make sure the meter and leads are rated for the voltages to be measured. There's also another thing when looking at meters, which is the fact that some meters, when you, for instance, plug your Harbor Freight meter into the wall and it's 120 volts, what will it read?
A percentage less.
It'll be 120 volts. It'll be right. If you take your fluke and you stick it into the wall, what will it read?
Exactly what it is.
Right, it'll read the same thing. Okay, what if you were to take a wave that looked like this, for instance? Because not all AC is sine waves. And measure that with the Harbor Freight meter.
As long as it's not over 250 volts, you should be able.
Yeah, but you'll get a number that doesn't necessarily make any sense. You won't get a value that's the same as looking at this.
Right.
If you use the fluke, you will get different values.
So the values would go up and down?
No, you would get a different value because the Harbor Freight meter is attempting to figure out what the voltage is based on what it thinks a sine wave looks like. The fluke is actually a true RMS meter. So if you're reading with a true RMS meter, it will actually tell you, and you may not care for the most part because most of the stuff that we deal with is sine waves. But if you're dealing with other waveforms, that fluke meter will actually tell you what the RMS value is. It's a true RMS reading meter. It does extra calculations on the inside. And because of that, it's a lot more accurate. So just another thing to look for when you're going to look for a meter. Most people aren't going to care, but when you go for your general or your extra exam, that's going to be on there.
It's going to be on there?
It's going to be on there.
It's called a fluke?
No, the fact that something is true RMS reading.
Oh, okay.
When you look at meters. Okay. Fluke just happens to be a really good brand. So used to measure electric current would be an ammeter, like an amp meter. You have to connect an ammeter in series with the circuit to measure the current. Unless, of course, it's a clamp-on ammeter, which is an inductive ammeter, which uses a core, a ferrite core and a coil. There are multiple different kinds of solder. There's lead-free solder. There's rosin core solder. There's lead and tin, which is a eutectic. That is the most popular, except that it still has lead in it. A lot of people like to get away from the lead. The one you don't use for electronic soldering is acid core, which is often used for like plumbing. This will destroy a circuit board very quickly.
I can see why.
Yeah. A cold solder joint, a nicely done solder joint is shiny. It looks like a little shiny volcano all the way to the top. If it's bumpy or rough, you can have a mechanical connection, but as soon as the weather changes or the ambient temperature changes, your solder joint is no longer connected because it was never electrically connected in the first place. It was a mechanical connection only. That's called a cold solder joint. And typically those will fail at the worst possible time. Okay, FM operation, frequency modulation. So it's important to note what frequency modulation is. What we're going to do is we're going to draw a frequency chart. And here is our center frequency. So 0 to infinity in frequency and amplitude. So this is our frequency center. When we speak into an FM radio, it will do this and move the frequency back and forth. So what we'll end up with is an area that is filled in with information that contains your voice based on how far the frequency is spreading. The amount to which it spreads is known as the deviation. So an FM signal typically takes up 10 to 15 kilohertz of bandwidth. So that's 10 to 15,000 hertz. If you are over deviating, you're speaking too loudly, what will happen to your signal? It'll go too wide. Well, that's not in and of itself a problem until somebody tries to listen to it, right? What happens when somebody tries to listen to that and this part of your voice isn't there?
It'll be distorted.
You get distortion. So overmodulation, over deviation, that's one of the problems you can have with FM. Amplitude modulation, on the other hand, looks totally different. Amplitude modulation is when you take a carrier. This is a carrier frequency. So with FM, we do this. Essentially, we change the frequency back and forth. With AM, we take the carrier, which looks like this, which is a constant frequency, and we take a modulating waveform, which is your voice, that looks like this, for instance, in time, and we use it to shape it. And so the whole thing ends up looking like this. This is known as the modulation envelope. And now we have a modulated AM signal, and we have a modulated FM signal. What do you notice about the amplitude of an FM signal?
Constant.
It never changes. That's right. With AM, your frequency doesn't change, but your amplitude does. Well, it turns out that static, like from lightning crashes, or static crashes from lightning, generate a frequency spectrum that goes from 0 to infinity. They raise the noise a constant amount at all frequencies. Static makes a lot of noise. What happens is you get an amplitude change over here, so you get crackling on AM when there's static. On FM, since it basically just adds amplitude to certain frequencies, what happens is that static has no impact on FM. The reason being that if it increases a particular frequency, you don't really care, because when you get when the signal gets into the receiver, you look at the amplitudes and you just cap it anyway. Say anything bigger than that doesn't matter, because all I care about is the frequency, not the volume. And that is why FM sounds so much better than AM.
Hence the song by Steely Dan.
Yep. No static at all. I'm dating myself, aren't I?
I did too. It's okay.
Okay, so FM. FM operation. What type of station retransmits the signal of another station? That would be called a repeater. All right, so we're talking about operating procedures. a type of station that automatically retransmits the signal of other stations. There are 3 different kinds. Repeater is literally a repeater. An auxiliary station is just kind of like a store and forward. It could be like a microwave link or something like that that's used to give a signal from one system to another. And then a space station. A space station is anything 50 kilometers up or higher. There are repeaters on the International Space Station. So it is both a repeater and a space station. A linked repeater network is a network through which one repeater is connected by a network to all other repeaters in the network. So if you can access one, your signal is retransmitted on all the other ones. In Oregon, we have one called the Peak Radio Association that I believe at latest count has 57 repeaters around the state all linked together by a combination of internet and microwave and UHF linkages. On the 2-meter band, your offset is 600 kilohertz. On the 70 centimeter band, your offset is 5 megahertz, which we talked about. There is something called CTCSS, which is a continuous tone carrier squelch system. CTCSS is a tone it's a system also known as private line or PL that was developed by Motorola as a solution to multiple different repeaters in the same area being accessed at the same time. So you will find this throughout FM radio, and essentially it's a series of 38 different subaudible, low frequency, low amplitude tones that are transmitted continuously along with your signal. If that's not present on a receiver that is expecting it to be there, the receiver will not accept the signal and not retransmit it. There's another one called DCS, which is digital coded squelch. It's kind of like a little frequency jumping sequence, whereas the continuous tone is a single tone. DCS is basically a continually jumping frequency bump that if that sequence is not present on your signal is rejected and not retransmitted by the repeater. So if you have the wrong offset or the wrong tone or the wrong DCS code, you will not get into the repeater. We run a newbie net called the Now What net. Like you just got a radio, you just got a license, and now what? Every Monday night here in Eugene. These 3 things are the most common things to have wrong. You have the wrong offset or no offset. We don't have a DCS, but the other one is that you didn't set your tone right. The reverse function, you remember that when you transmit with an FM radio, it changes frequency so that the repeater can hear you properly. Reverse allows you to listen on the repeater's input frequency. Why would you do that? If you want to hear if somebody else is nearby you. Because if you can talk with each other directly, you don't have to use a repeater. If your FM transmission audio is distorted, you are probably talking too loudly. The reason being that you are over modulating and over deviating, and the other person is missing part of your audio. How do you call another station? Who here's got their license? Does anyone here have their license yet? I thought there was one. Okay. So basically you would say their other station's call sign and then your own. So if I was calling N1ABC, I'd say N1ABC, N7JI. And that's it. If I was just listening on a repeater, I wanted to announce my presence, I would just say N7JI monitoring or N7JI listening. Transmitting on the same frequency as you're receiving, that's known as simplex. Simplex is very useful because it frees up a resource. Unless you need to be using a repeater, if you can avoid using it, don't use it. Right? If you want to be talking to one individual person half a mile away from you and your line of sight, then you should do that. Unless you really need somebody else to be in on the conversation. Why are simplex channels designated? Again, repeaters are a resource. The bigger the repeater system, the bigger the resource. So like for instance, the PRA, the Peak Radio Association system with 57 repeaters, that's a big resource. If you're down the street from somebody, there is absolutely no reason to tie up that whole system when other people might actually need it. So that's used for big communications, like across the state. The national simplex calling frequency is 146.52. Commit this to memory because this goes in pretty much every radio that you will ever program. That's basically your backup channel for looking for anybody. And I found out this week when I was in a class that that's actually the basis for something called the Wilderness Radio Protocol as well. That's the frequency that they use. High frequency operation, you have access to 4 different bands based on
your license.
Based on your license. And let me, right there, notice everything that's hatched. Right here, you have 10 meters, 15 meters CW, 40 meters CW, and 80 meters CW. You may not use it, but you need to know that it's there and that your license class covers it. Part of that is doing this for the test. The meaning of the term CQ, CQ means I'm seeking you or I'm looking for anybody to talk to. CQ, CQ, CQ. Before calling CQ.
You would say it like that, CQ?
CQ,
Yes.
CQ,
Okay.
CQ. November 7, Juliet, India. Calling CQ. What should you do before calling? Make sure that you have privileges where you think you're going to be calling. Listen, 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 and then ask if the frequency is in use. Because you may only be able to hear one side of a conversation, depending on where you are and where the other people are who are using the frequency. Propagation does not give you full coverage of everywhere. So you might be able to hear a person who is within range of you, but they're not talking at the moment. They're actually talking to somebody else. You don't want to interfere with them. So how do you call? If a station is calling CQ, you reply by using their call sign and then using your own. So basically, Bob, this is Scott. The same way you do that over the phone, except that you use call signs instead, and they have to be in the right order. When making on-air test transmissions, you have to identify the transmitting station. The FCC rules say that whatever you're doing, you have to identify. You have to identify a transmission. The rules also say that you have to identify every 10 minutes and at the end. So if you're doing a test transmission, you tune up your radio, N7JI. Now it's legal. Got to make it legal. Okay, we use Q signals. Morse code uses a lot of Q signals. 2 of the most common ones, QRM, means that I'm getting interference from another station, man-made noise. QSY is the term that means I'm going to change frequencies. And again, these came from Morse. Sometimes you'll even hear them on voice. So QSY means change frequency. Both of these can actually, any Q signal can actually be a question as well as an answer. So QRM question mark means, are you getting interfered with? QSY question mark means, do you want to change frequencies? And an answer would be it without a question mark. So a band plan. This is a band plan. The FCC does not tell us how to run things, which is nice. What they tell us to do is stay, for instance, let's look at the 6-meter band, stay between 50 and 54 megahertz. That's it. That's what the FCC says. We like it that way because then we can kind of decide how to do things. If you look at the NTIA chart, you will see that, oh, come on, don't do that. Problem is it's slowed down. There's 50 to 54. Okay. All right, everybody see 50 to 54 right there? There's 50, there's 54. That's our 6-meter band. They don't list this part is for voice, this part is for digital, this part is for code, et cetera, et cetera. And again, we don't really want them to do that. We want to be able to be as flexible as possible. Sometimes there are things that are codified. For the most part, the band plan is not written in stone, but it exists and is agreed upon to keep peace between operators. So notice that we have the red, that's Morse code only. The olive, which is single sideband and weak signal, that can be Morse code because you can use Morse code anywhere. But it also allows weak signal. Notice it says no FM. FM is a bandwidth hog and it blocks people from using frequencies. So no FM there. Notice this one now says radio control. This is for literally like remote controlled aircraft. And then up here we have more yellow, that's digital. And then pink is FM simplex. And then we have repeaters as well. So that is a band plan that goes above and beyond what the FCC rules say. And the reason we do that is to keep people from interfering with each other when doing specific things. Two stations transmitting on the same frequency, when they interfere with each other, nobody owns a frequency, even if somebody may say they really do. They don't. Public service and MCOM. ARES. Okay, so this is a very important distinction between ARES and RACES. RACES is administered by a local civil defense organization, right? Civil Emergency Services. So this is actually run by a governmental organization. ARES is a completely volunteer service that is run by a group of hams who have basically gotten in touch with an agency and said, we're here to help. ARES, you do not have to be registered with the governmental organization. With RACES, it is more official and you're specifically for civil emergency services. So when you see RACES, that means government. When you see ARES, that means volunteer. They're both volunteer, but RACES is a little more official. And also ARES, because it is a volunteer thing, is not written into the Part 97 rules. Notice that RACES is actually written into the Part 97 rules, which are in the FCC documentation. Okay, net control station. Okay, who wants to be part of a net?
I do.
Okay.
I'll do it.
Who was that? Give me a name.
Sean.
And who else?
James.
Okay, here we go. This is November 7, Juliet, India. I'm just going to go by Scott. This is Scott calling net to order. Do we have any check-ins?
You have Sean.
Okay, Sean, thank you for checking in. I've got you on the roster. Thank you. Please stand by. Do we have any other check-ins? Please come now.
You have James.
Okay, we have James. Thank you, Sean, and thank you, James. Please stand by. Do we have any other net check-ins? Please come now.
Steve.
Steve. Okay, thank you, Steve. We have Steve checking in. Please stand by. And okay, so we're going to move to this. We're going to move to the section of the net. Let's see, James, do you have any traffic for the net? Over.
I do not have any traffic for the net.
Okay, thank you, James. No traffic. Steve, do you have any traffic? Over.
No traffic. Over.
Okay, no traffic from Steve. Sean, do you have any traffic for the net?
No traffic monitoring.
Okay, so what we're going to do is, if anybody has any emergency, any traffic, please get the attention of net control by just saying net control this is, and give your name, and we will take your traffic. Other than that, we're going to just keep the net on standby, and we're going to keep it open for about another 30 seconds. Do we have any other check-ins? Please come now. Okay, nothing heard. So this is Scott running our net. I'm net control. Anyone who has any traffic should please come through me. And we're going to make one last call for any check-ins or traffic. Please come now. Okay, quiet out there today. All right. Well, net control wishes to thank all stations who checked into the net. Thanks for making yourselves available. And it is 11:44 p.m. or sorry, 11:44 a.m. Pacific time, and our net is officially dissolved. Thank you very much. The frequency is returned to normal use. Okay, so at that point, James and Steve and Sean, you guys are free to go because I dissolved the net. Thank you for standing by. So, okay, so what did you hear happening there? What was my job?
Coordination.
Facilitator.
Coordination and traffic cop, right? I'm the net control station. Notice I asked for traffic. What's traffic?
Messages.
Any messages, right? If there were any messages, they would be expected to be in an official format that, you know, we would be able to spell out and pass from person to person. It would be expected that unless, for instance, Steve and Sean could hear each other, and I knew that, I would basically serve as the traffic handling station between the two, passing it back and forth. And then we deal with confirmation, because if you're doing a network, your goal is to pass traffic back and forth. That's why you're there in the first place. Accuracy is really important. Speed is important, but not as important as accuracy. So there are certain things that we do. For instance, if let's say we had some traffic regarding Karsten Reudel, right? And I'd say, okay, traffic was from Karsten Reudel. I spell Charlie Alpha Romeo Sierra Tango Echo November Romeo Oscar Echo Delta Echo Lima. Do you copy? Because most people are not going to be able to spell that. I have it written down on a piece of paper. I want to make sure somebody else has it. I'm going to do it letter by letter. So your goal is to get messages across as accurately as possible. So let's go back to our book and see where we got to. Okay, typical duties of net control: call the net to order, direct communications. Standard practice: unless you're reporting an emergency, transmit only when asked to. Traffic is messages. The job is passing messages exactly as received. You use the ITU phonetic alphabet to make sure that things that are not common spellings. For instance, we just did one this past week in our class where somebody's name is Jerry, right? Well, there's a couple different ways to spell Jerry. So we actually spelled it Golf Echo Romeo Romeo Yankee with a G, not with a J. Yeah, Bear. Yeah, Bear County. Exactly.
So Stephen, if Stephen did have traffic, you'd just listen to it, write it down, and then repeat it back to the net verbatim.
Repeat it back to him, and then make sure that it was received properly, and then it was forwarded to the right person. Because it might be that the net is far bigger than just us. It could be that Stephen, for instance, is participating in another net somewhere, and he is passing traffic that originated from somewhere far away.
Okay. So the recipient would probably also be part of the traffic.
Yeah.
If they were trying
So
to get it to somebody
basically,
else.
you have an originating station. You have a destination, an origination location, destination, message information, where and when it was generated, by whom, who approved it, what the text is. And so all of this is, it typically follows something called the ICS 213 standard. Sean, I'll bet you know about ICS 213.
Oh yes. Oh yes.
ICS 213 is a standard for message handling in the incident command system. And it is used everywhere. and there are slight variations in ICS 213 from agency to agency, but by and large, it follows the incident command structure, which, basically has like an incident commander, and then you have different divisions underneath an incident commander for like logistics and communications and stuff like that. So it works well for passing messages in that framework.
And if you're entirely too busy, you could have a secondary station be your scribe, and it's perfectly legal.
Yep.
So, if I could ask a question, is this similar to like how when I was stationed in Korea back in, I want to say 91, that I sent a Marsgram to my mom and she got it in Los Angeles. Was that
similar?
From Vietnam?
Yeah, similar. Mars is a military affiliate radio system. Yep, same kind of thing. There are Mars nets all over the place all the time.
And believe it or not,
even now
in Ohio, we have a MarsNet for Patterson.
Yep.
So this trafficking thing, is that what they were using like in West North Carolina when people on the other coast were wanting to find out how their families were?
That's to a certain degree, yeah.
Okay.
I mean, there's something called a radiogram, which is similar. There's a Marsgram. There's an ICS 213. Essentially, it's just a standardized method for passing information. Typically, there's emergency traffic, and what you're talking about in Western North Carolina when they had the floods, that was largely health and welfare, we call it. Which is not emergency, but can be just as important. It's basically getting information on individuals to where it belongs so that they can, kind of breathe easier.
Yeah.
And another part of it is that it might be that, like we do a lot of nets locally, for instance. It might be that you may be the only station in a geographic area that actually is up and running. In which case, what's your local net? You don't have one, right?
No.
The person that you're able to communicate with could be 400 miles away. That might be the nearest place that you can communicate with. In which case, your 2-meter radio isn't going to be of much use. In which case, then you say, okay, well, I can operate on HF radio and communicate with somebody using HF radio. Which is why, we really do recommend that people who do MCOM and are really serious about it, get a general class license and really take advantage of everything that's available, because you never really know what you're going to be asked to do, and and ultimately you're going to want to use something that will work. It's just another tool in our tool bag. Okay, the check in a radiogram header. Check is a count of the words and word equivalents. So words and numbers and things like that. If it turns out it doesn't match, that's basically a parity check. And we can say, this doesn't work. Please send it again. It doesn't match. When do the rules apply? When do the rules not apply to the operation of a ham station? The answer is they always apply. However, part of that rule is that if we have a case of immediate safety of human life or protection of property, like a dam is going to break, or it's like just happened in Texas. There's a flood coming. There's a bunch of people that are about to drown, which sadly did happen in Texas. If somebody's got a radio, the rules be damned. Go ahead and use it. Okay, satellites. Who can talk to the International Space Station on the VHF bands? If you have a technician class license, you have access to the VHF bands, and you can talk to the ISS. If a satellite is operating in mode UV, that is UHF uplink and VHF downlink, the most common UHF frequency is the 70 centimeter band. ISS is right now operating on 437.800 uplink and 145.99 downlink, or 145.800. There's also 145.99. They're in different modules, different transmitters and different modules of the space station. Amateur satellites, some of them are single sideband, some of them are FM, and some of them are Morse code and data. All three are valid. So, could you launch a satellite with an amateur license? What do you think?
Some money.
Yes.
If you have the money and you have a ride, you can build a satellite and launch it.
Do you have to launch it from a specific place?
You have to, yeah, it has to fit into a specific spot in the orbit.
A CubeSat.
CubeSats are great for that.
Here on Earth. I mean, here on Earth. You got to go someplace specific.
Well, you've got to find a launch vehicle. I actually know somebody who's up in Portland. Who's here from Portland State? Where's all of our Portland State people? Okay, so were you part of the group that went down to California to get the satellite up on a rocket?
I was not. That was before my time.
Okay. But you guys build CubeSats, right?
Yes. Yep. It's out in orbit right now.
And that's ORSAT 0.5?
That's the one.
That's the one. Okay. And so a CubeSat is 10 by 10 by 10 centimeters floating around in space.
How long will they stay up there?
Until gravity takes over.
They're LEO, right?
Yeah. It's about 200 miles up. And once basically what happens is because the atmosphere goes up to 600 miles, whenever something happens, like a solar flare or something, or big aurora, the atmosphere kind of expands and it increases the drag on satellites, and eventually they will slow down and they will deorbit in a puff of flame.
Does that size include the antenna as well?
Brian?
It depends on the design of the antenna, but no, it usually would like fold up inside the CubeSat and deploy once it's out in space.
Okay.
Do you guys use the hot wire method?
Yes. Where you melt the line so that they can unfurl.
Yep,
Yeah,
spring-loaded antennas, and you basically melt the fishing line.
Yes, that's right. With a transistor or something, yeah, I can't remember.
A one-time use device.
It's very effective, and as it turns out, if that for whatever reason fails, the sun will do it for you eventually.
Oh, really?
Yep.
Okay.
They have rideshare programs with a lot of the launch providers.
Well, I know that Andrew has gone down to California at least once or twice, right?
Yeah.
To get a ride.
Yep.
And okay. All right, let's see. What is the impact of excessive radiated power on a satellite uplink? Multiple users could use it at the same time. If you're transmitting with too much power, then you could block access by other users. This is typically true on a linear transponder. So it could be listening across a wide range of frequencies. Transmit too much power, you block other people. There's a beacon that reports on the satellite itself at all times. Beep, beep, beep is a beacon. The beacon could also contain other information. It could be over Morse code. It could be containing data that says that the satellite temperature is 72.5 degrees, and its altitude and GPS position are this. Basically, that beacon that's sent down has all kinds of telemetry information, and anybody can listen to it because it's just a receiver that you use. But if you're transmitting up and you hear the beacon, your voice or your signal should be about the same strength as the beacon. It's a good way of checking to see whether or not you're overloading the satellite. The word LEO was mentioned. That's a low Earth orbit satellite. Here we go. Satellites in low Earth orbit are between 99 and 1,200 miles up. The ISS is about 200 miles up. It orbits once every 92 minutes or so. A satellite beacon, again, contains information about the satellite, telemetry information, health and status of the satellite. Anybody can receive telemetry information. Satellite tracking software. Satellite tracking software is a wonderful thing. You basically enter these things called Keplerian elements, and it spits out a map of where the satellite has been and where it's going to be. Because you know where it has been and where it's going to be, and in particular where it is at any particular point, you know exactly where to aim your antennas. And that could be just aimed by hand even. I've done that. Doppler shift, we covered a little bit. Satellite's movement is fast even compared to the speed of light, which makes the frequency change in frequency, the signal change in frequency. When it's approaching, the signal gets higher. When it's going away, the signal gets lower in frequency. Spin fade, satellite is rotating constantly. As it rotates, the antennas might come toward you and then away from you, and could even be eclipsed by the satellite itself. If the antennas are turned the wrong way, you won't hear the satellite, and the satellite won't hear you. Operating activities. Okay, so there was, when we were listening on the air a little while ago to, let me see if I can bring that up, see if I still have it open. I do, Northern Utah Web SDR. And I'm gonna bring the sound up. Hopefully everyone can hear it.
Yep.
Okay, notice that they're going pretty fast. Kilo 2 Mike. K2M is part of the 13 Colonies Special Events Station, which is kind of like a contest. People all over the world are trying to work all of the original 13 colonies, which are on using special call signs for just a week. So the goal is to get as many people, as many contacts as possible, and that's what we're listening to. And just on to the next one. And notice there's virtually nothing in the way of brakes. Because here's another one, Kilo 2 Foxtrot.
Kilo 2 Fox, Maryland. CQ 13 calling, Kilo 2 Fox.
Notice him saying CQ. There it is.
Kilo Charlie 8, Fox Echo Lima, 59 Maryland.
What else do you notice about what he said?
So Charlie 9, Charlie Mike Tango, 59 Maryland.
State of origin.
2 Fox.
Well, he's in Maryland, but listen to what he's using for call signs.
59 Maryland. K2 Fox.
K2 Fox.
Kilo Golf 5 ready to Japan, 59 Maryland. Thanks. Kilo 2 Fox.
Do you notice anything that is not phonetics? You notice anything that was not using phonetics in all of that?
You said K2 Fox?
Yeah, okay. Well, that's his own call. But when he's repeating other stations' call signs back,
He said his location.
he said, yeah, okay, but still Maryland. But anytime he's saying a call sign, either his own for the most part or the other station, it's all phonetics. And how much other chit chat did you hear?
Little.
None.
Virtually nothing, right? Because what was the point of what he was doing? It was to get as many stations, as many contacts as possible, because it's a limited time event. So let's see about this one.
Good signal. Came back up again. November 5 Whiskey Mike Quebec 59 here into US 1217. Over.
This is somebody doing a Parks on the Air or a POTA event.
Yeah, thank you so much for New Mexico. If you stand by, I've got a second operator for you.
A little more laid back, right?
November 5 Whiskey Mike Quebec. This is November 0 Hotel Romeo Alpha, Park US 1217. Copy. Yeah, thanks for that. 5.
So different events often bring in different operating styles, different degrees of trying to get things done. Some of like a long conversation is just known as a rag chew. That could be half an hour long where you're just talking back and forth with somebody. Contesting on the other end is basically what we heard that guy Kilo 2 Fox doing, essentially trying to get as many contacts in a given period as you can. That's actually a special event, technically not a contest, but it's behaving like one. When you're contesting, you only send the minimum information needed for proper exchange so that you don't slow the other guy down.
Basically, like your field day exercise where you're making as many contacts as you can. You're always fighting everybody else to get that particular state.
Mm-hmm. Exactly. There's an end goal, and you're basically trying to achieve something. Grid locator. That is actually one of the things that I sent everybody. It looks like this. The entire world is broken up into grid squares. The reason we use them, if you, for instance, look at Minnesota, is that Minnesota goes from like EN 18 all the way down to EN 42, 43, EN 43, and lots of other grid squares in there. Minnesota's a big state. If let's say you're in Wisconsin and you're pointing your antennas at Minnesota, you could be almost due north, you could be due north, you could be due south, or you could be due west, or anywhere in between. So grid squares give you a little bit more resolution as to being able to point and figure out where somebody is. So the whole world is broken up into grid squares. 2 letters, 2 numbers, and then there's actually 2 lowercase letters that are after that are broken down even further. And it's kind of funny that they call it a grid square because it's actually a grid rectangle. Each one of those zones is 2 degrees in longitude by 1 degree in latitude.
Where's Hawaii?
Hawaii is over on the other map. So there we go. Like BL01, BK19, and Alaska as well. Notice Alaska has a lot of grids because as you get closer to the North Pole, the grids get smaller.
If they were using these grid locations, they would say it just the way you just said it.
Charlie November 84.
Okay.
Yep. Charlie November 84, Echo November 55, etc., etc. Which of the following methods is used to locate noise sources for jamming? Radio direction finding. If you've ever heard of something called a bunny hunt or a fox hunt or a direction finding exercise, you use a directional antenna like a Yagi, typically a handheld Yagi, to go around and figure out where the transmitter is hiding. Okay, so now we're into internet hybridization with radio. There's a lot of it. Something called IRLP, which is the Internet Radio Linking Project, uses VoIP, which is Voice over Internet Protocol, essentially digitized voice, to take audio from radio, switch it over across the internet, and then back to radio on the other end. So the same way that we use telephone calls, that's all digitized voice when you're using the phone. That's what we do with VoIP over the radio. Echolink is a telephone and computer-based system whereby you sign up for Echolink with your license. And once you have signed up and been assigned an ID, you basically then have access to anywhere that you have an internet connection. Let me unshare this. You then end up with an application on your phone or on your computer, and you can pull up repeaters like, I don't know if there we go, all over the world. So basically, you're looking at connecting your phone, acting as though it were a radio, taking your voice and digitizing it, and sending it to internet-linked repeaters all over the world. I actually use that when I'm traveling because I travel a lot for work, um, a lot to the deep south, a lot to Europe, to South America. If I want to connect to my local repeater, I just dial it up using Echolink, and I can talk to my friends on the radio wherever they are in their cars back home. Okay, Echolink again. You do not need a radio to initiate the transmission. IRLP, if you're using an IRLP node, DTMF is also known as touch tones. Every radio that has a push button number pad like this, when you're transmitting, if you hit one of those buttons, it will transmit touch tones. Enter the right code, you'll get tones. You can use them to access the system. An amateur radio station that connects other amateur stations to the internet is called a gateway. All right, and now we're into rules and regulations. So how about a 5-minute break, everybody?
Sounds good.
Hey, when we get back, I have a little thing to talk about.
All right, don't forget.
No, got it up.
Okay. Ask your question if you're back.
you're about a 5-6 here into Park US 1217, over.
Roger, Roger, John. Thanks for pulling me out, brother. You're about a 5-3 in November. Charlie, standing by for your better half.
Yeah, you...
CQ, 13 colonies, K2M. Kilo 2 Mike, CQ, K2M. CQ, 13 colonies, K2M, Kilo 2 Mike.
Does your peak radio repeater system have a SDR?
I don't think so. All right. Ask the question now.
It's not a question. It's something that I heard, and the military folk might know about this. Specifically, anybody that was in the Navy. There was a system called Fleet Satcom that was used. It's a satellite system that was used by the Navy to send voice, analog and unencrypted, and eventually encrypted. But people in Brazil found the frequencies, and they're using souped-up rigs to use it as a open class repeater. So if you tune to the frequencies where the satellites are, they're geostationary satellites.
Huh.
You'll hear all this traffic from them.
What's it called?
Fleet Satcom.
Fleet Satcom.
Was the system. And the constellation, there's still probably 2 or 3 satellites up there. The other thing was when I was young in the 90s, where my father used to park his vehicle in New York, the Secret Service used to have their vehicles there. And you were talking about using the moon. They showed me a system where they went and sent a bounce signal from a radio car back to Langley for a voice and data check. And it was unbelievable. That's what got me the radio.
And that was used off the moon?
Off the moon. In Manhattan on between 53rd and 52nd Lex. That's where they were, because they would always park there when the president was at the UN. So the Secret Service would load their vehicles in this parking lot, and they were nice. The radio guys were extremely nice and knew I was interested and showed me all the gear, and it was just unbelievable.
That's pretty cool.
So Fleet Satcom, I'll send you a link.
Okay, hold on a sec. I've never watched this video before. I'm just going to bring it up because it seemed interesting. I hope it's not embarrassing.
I got it right here. Moon bounce in the backyard with N7JI. He gave me a minus 27 on my signal. He's minus 24 is what mine says.
Okay, this is WSJTX. This is what that software looks like. Essentially, it's, again, canned messages being sent back and forth. Very, 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 very low speed communications, but very, very resilient.
And I'm talking to him scheduled on HB9Q logger, okay? This is 50 watts on Q65 60 Bravo. So 60 seconds of subband B, learning a lot about this stuff. I got the Mirage amplifier only running about 50 watts because the battery on the, I've been doing this practically all night. It's like 11:30 right now. See, I'm only at 50% power because this is dead. So I can't put the 10 volt or the external LiPo from this into it to get 10 watts. So I'm driving the amp with 5 watts. It should be around 50 watts output.
Okay, he's about to show his antenna
I moved
system.
it over here. I'm sorry, I'm so excited. Okay, here it is right here. Look at that, Armstrong method. Wow. I didn't do anything but just go like this, right? Boop. Right there. That's good for another like 2 minutes. I bounced the signal off the moon with a friggin' ICOM 705 and an antenna I'd had in a box for 8 years at 50 watts, right?
Okay, there you go. So things that you can do that kind of defy logic. So that's moon bounce. Okay, so here we go. Rules and regs. Okay.
The boring part.
The boring part. This is the, the stuff that you have to learn because you have to learn it. And there's no other way to do it except memorizing it. Okay, the FCC governs amateur radio in the United States, Federal Communications Commission. Part 97 is the part of the rules that govern amateur radio. And right in the very first section of the FCC rules governing amateur radio, we are going to take a look at that really quickly because just the first section covers a big part of what it is that makes us exist. So here we go. We're going to share the screen. Okay, so this is part 97 of the FCC rules. A little bit of light reading. Here we go. That is the rule book regarding amateur radio in the United States. So there's a lot of stuff in there. I do not know it all. Most people do not know it all. Right in the very first paragraph called Basis and Purpose, notice what we have. The rules and regulations are designed to provide an amateur radio service having a fundamental purpose as expressed in the following principles. Okay. The value of the amateur service to the public as a voluntary non-commercial service, non-commercial communication service, particularly with respect to providing emergency communications. So if you are interested in amateur radio for emergency communications, congratulations. That is one of the 5 reasons. In fact, the first one listed that we are given frequencies and allowed to exist. Number 2, a proven ability to contribute to the advancement of the radio art. If you enjoy technical stuff, congratulations, that fits in. You want to come up with a new protocol for communications? There you go. Come up with a better antenna design? That's for you. Advancing skills in the communication and technical phases of the art. Okay. You enjoy soldering. You enjoy designing circuit boards. You enjoy doing programming, things like that. That fits right there. Expansion of the existing reservoir within the amateur service of trained operators, technicians, and electronics experts. If you get good at, if your intent is to get better at what you enjoy doing, you fit in that one. International goodwill. My favorite story there is when I was applying for my first job, and it was at a company where I had to do I had to go through a security check, and they wanted to know if I had any contacts for my clearance, if I had any contacts with anybody who lived in foreign countries with which the United States was unfriendly. This was back in the late 80s, early 90s. I said, well, Romania, Hungary, East Germany, Czechoslovakia. I could go on and on and on. It's like, oh, how do you know all these people? I said, amateur radio. He's like, oh, you're fine. That right there, we were still at odds with them. That was behind the Iron Curtain. But the fact that it was ham radio meant that it was a part of international goodwill, and it was not a concern. So that's a big part of it. There are countries with which we are not in good, not in particularly great standing with, yet we still talk with them on the air and vice versa. Non-commercial or not, we like to be apolitical. We enjoy our communications person to person and get to know each other. Okay. We're going to go back to the book. Okay, back to the book. Okay. Here we go. A beacon is information that it's a signal that's being sent out with the intent of not receiving an answer. It's a one-way communication for observing propagation or experimental activities. It could be weather, it could be river depth, it could be temperature, it could be any number of things. It could be propagation, saying, hey, we're hearing somebody from Las Vegas today. They don't have an expectation of ever receiving a report. They're just sending out a signal saying, here I am. I believe when you actually get to your general exam, there are specific things about beacons like power levels. I think you can run 100 watts max. And you can only have one of them operating on any band from any given location. So that's the difference between
That's not considered broadcasting?
We don't broadcast. Broadcasting is meant for the general public. We do one-way transmissions, which are meant for amateur radio.
Okay.
There's a distinction, and that's a very good distinction that you bring up. So yeah, we're not allowed to broadcast because broadcasting is meant for the public. Broadcasters also typically have to pay. So
license.
Yep. Oh, we're licensed, but broadcasters have to pay for their licenses, Okay, Part 97 definition of a beacon, again, is a one-way communication for transmitting information. Part 97 definition of a space station, anything 50 kilometers up or higher is a space station. When are you allowed to interfere with other amateur stations? Even if they're really annoying you? The answer is never. Which of the following entities recommends transmit and receive channels and other parameters for auxiliary and repeater stations? Okay, so wherever you happen to live, there is something called a volunteer frequency coordinator. The frequency coordinator is part of a group of people that figures out what to do with the band plan, right? So here's the band plan. The FCC doesn't tell us what to do with these frequencies, with a few very small exceptions. All they say here now within the band plan is, well, we have these orange. The orange are repeater frequencies. But they don't say, even in this band plan, how to set those up. It can vary from location to location based on requirements of that particular area. So there's a volunteer frequency coordinator, which is a very thankless job, where people are tasked with the job of figuring out what repeaters located in what places can coexist with others without causing interference, and assigning frequencies for repeater pairs in that region. So the hams who are in an area and have a repeater pick the unlucky people who get to be the frequency coordinator. And basically the frequency coordinator decides who gets to be on what frequency at that point.
Yeah, in Ohio here we have Ohio Area Repeater Council, and you submit, then they assign.
Yep. And once you have a repeater, then you're eligible to pick the people who get on that board. Okay, so one thing to be said about amateur radio is that how much money does it cost to get a license?
Just your testing fee.
Testing fee, and the FCC will charge a $35 licensing fee to process your paperwork. It used to be free, now they charge. If you're under 18 and there are avenues to get it completely for free. Essentially, though, it's done once every 10 years. It ends up costing $5 a year. The government does not do a lot with $5 a year per person. They just don't, right? There's not a lot that they can do and not a lot that they want to do. So, for the most part, the United States government, the Federal Communications Commission, is very hands-off with regard to amateur radio. And they want it to be that way. And honestly, we're happy to have it that way as well. But what that means is that if there are bad actors that give us a bad name and a black eye, most of us really want that to stop. So we are what's known as self-policing. You know, there's a group of people who are volunteer monitors that work with the ARRL. The American Radio Relay League is the member organization of hams in the United States. They work with the FCC, but are not a part of the FCC. And the FCC has basically said, you know what, figure out as much as you can to keep the peace. And that's what we all try to do because the FCC doesn't get enough money to make it worthwhile for them to do anything with us. So when it comes time to frequency allocations being reallocated, the ARRL is the organization that goes to Congress and goes to the FCC and says, you know, we have lots of activity there. We don't get any money, but you know, we don't give you any money, but our members last year contributed, you know, they contributed 60,000 hours of time volunteering for this and 100,000 hours of time volunteering for this kind of thing. And, you know, at $80 an hour or even $30 an hour or $20 an hour, that's a lot of money. So, you know, and we do this because it's for the public good. So maybe you shouldn't give our frequencies away. So that lobbying comes from the fact that members pay dues. So we are literally a crowd-funded organization and have been for the last 110 years in support of American amateur radio operators. So my little plea is to, when you get your amateur radio license, please consider joining ARRL to help out and preserve what it is that we do have. Protect our frequencies and help out with educational stuff and advocacy and things like that. So, all right, now we're into the band plan. Okay, 6 meters is 50 to 54 megahertz. And so we're going to go over to here. And the question is, what frequency is in the 6 meter band? Well, we can go through our calculations and say 6 meters would be 50 megahertz. Well, it turns out that 49 is closer, but 49 is not in the band because you simply have to know what the band limits are. And it's 50 to 54. So 52.525 is in the band. 2 meter band contains 146.52. On the 10 meter band, you have phone privileges as a technician. Phone is another way of saying voice. So you have voice privileges on the 10 meter band. You can operate from 28.3 to 28.5. Notice that that band goes from 28 up to 29.7. You have that little blue hatched swath in there. It gives you a little taste of what 10 meters is like. The thought being you're going to get so hooked that you're going to upgrade and get your general, in which case then you'll have access to the whole thing. And all these other bands, at least some access to all of them. Okay, moving right along. On every band, 50 megahertz and above, you have some access to single sideband. And why do we use single sideband? Single sideband is very good for weak signal work. It works much more effectively than FM. Morse code only. The only way to know that it's there is to look at these bands and see the little red areas and see that on 6 meters and 2 meters and 1.25 meters, there's a small red area, which is Morse code only. The answer in this case is on this 6-meter section and on this 2-meter section. This is a weird one. I've never used it. This came from a deal between the FCC and the federal and UPS about 25 years ago. That 1.25 meter band used to be from 220 to 225. It was then split because UPS needed 2 megahertz to run a package tracking system. So they traded this little weird 1 megahertz disconnected segment for 2 megahertz between 220 and 222. This is for fixed digital message forwarding systems only. I don't even know exactly what that would imply. I assume it's literally just that. I've never known a single person who used that frequency band for that. But apparently you can. And if you can, it needs to be on the test. So. Okay, so we're going to look at the frequency lists. We're going to look at the band plan again. And for instance, let's take a look at the 12-meter band. What is the upper edge of the 12-meter band?
24990.
Okay, and what's the lower edge of the 12-meter band?
24890.
Okay, so the FCC specifies the only thing they tell us is this is your playground. And you may do anything inside that playground so long as it's legal. But thou must stay inside the playground. You cannot leave. So this is why another thing we can do is if you look at, for instance, FRS radio, GMRS, those work in channels. Those frequencies that they have are very specific. The modes, the transmitting, the bandwidths, everything is defined in the rules that govern those radios. And when they ship them, that is exactly what they do. They can do nothing else. Where can we tune between 24890 and 24990? Where can you set your frequency? Where can you set it to?
Anywhere that you're allowed.
Anywhere within that range. That's right. It could be 24.94286.539. There are no channels. We have a band. We have a space. One thing that is important when we do that, however, is understanding what that implies. So let's say this is that band. We go from 24.890 to 24.990. The rule is that we have to stay completely inside. Let's say you're operating single sideband and your radio is tuned to 24.989 and you're transmitting. What is the bandwidth of an upper sideband signal? This is what an upper sideband signal looks like. How wide is it?
Is it 150 kilohertz or is it 15? One of them.
No, somebody who remembers this.
Is it 6K?
3 deep.
3 kilohertz.
That's the rules of 3.
Yep, 3 kilohertz. AM would be the other side as well. and this is another 3 kilohertz. And this is the difference between upper and lower sideband. This is upper, this is lower. Okay, so if you tune your dial frequency to here, and I draw that band, and I draw that that transmitted signal, it will look like this. What's the problem?
You're
Out of band. Yep, your
band,
signal
yep.
has to fall completely inside the band. This is why it's important to know when you're talking about different modulation techniques, how much space they fill up. This takes up 3 kilohertz. So what would be the highest frequency that I would ever want to tune to?
97.
21.
96.
That would be 24, 9, 8, 7, which is 3 kilohertz below the edge. If I do that, then my signal should fall inside. Unless, of course, my radio is off by plus or minus 1 kilohertz on my dial frequency, in which case it might actually be right here, in which case I'm out of band again. So that's why it's important to understand what it is that you're doing, and the fact that you need to know whether or not your radio is accurate frequency-wise. You need to know whether your transmitter drifts in frequency over time. So there's a lot to understand about what it is that you use. With great privilege comes great responsibility. We're allowed to do a lot of things, and there are a lot of ways to get in trouble. So that's why, you need to understand what it is that will keep you from getting in trouble.
What happens if you go out of band?
If you do it once, nothing. I've actually seen somebody do it, and I sent them an email to which I did not get a reply. I guess I really didn't expect one. If you are a habitual repeat offender, what might happen is that you will get a note from a volunteer monitor, which is watching the bands. This happens a lot during contests and during de-expeditions when everybody is like going crazy to try to work somebody and trying to find an open space, and somebody's not paying attention. But if you do it all the time, we have volunteer monitors who are, who basically they want to catch things before the FCC gets it. Because if the FCC gets something that says, hey, this person repeatedly violated the rules, they are a habitual repeat offender. The fines are similar to what a commercial TV or radio station can get fined, and those are pretty significant. I mean, like if you interfere with somebody or interfere with like a fire department or something, you can get fined $25,000. It is not a small amount of money.
They require a lot of evidence for that.
Depends
Or
what it is. The FCC is very good at acquiring evidence, because once it gets handed over to them, they have a lot of tools that you don't have, that nobody else has, as far as being able to triangulate and record and transmitter fingerprinting and things like that.
So basically, you'd report me, and then they would just come and look at me, and figure out if what you said is correct. Okay.
Yep. Yeah, they'd have to gather their own evidence, but
okay,
it almost never gets to that point, because for the most part, there's it's not like you just put up a station and started operating, right? You went to the effort of getting a license. You went to the effort of studying, right? You actually went to the effort of making an effort, like a concerted effort, to go get a license. You're probably not going to risk it for something stupid.
Sure.
So
that makes sense.
Some people do, but
right.
Now the guy in California that got popped by the FCC for CB ban, citizens ban, he got popped. Was it $250,000?
Something like that. They can put out a lien on your house. Yeah.
Crazy.
Yeah. All right. So I saw a question fly across. What was the question? Somebody see it?
What if you radioed to a fire department radio if there was a fire? Would that be okay?
See, and that's where, okay. What are you allowed to transmit on the fire department frequencies?
I'm going to say no.
Typically, no. Okay. Do you have a cell phone that could work?
Potentially, yes.
Potentially, right. Okay. Are you in a place with no cell phone service?
Depends.
Depends. Is there imminent danger?
Depends.
It depends, right? So you, as the person who is doing that, would have to make a justifiable decision and have to be able to justify it to say there was no other means by which to do this. So yes, but there has to truly be no other means. There was a guy a few years ago in Idaho, I think. It was either Idaho or Montana. And he was fined $37,000 for getting on wildland firefighting frequencies and reporting the location of fires. Now, you would think, okay, well, that's helping them, right? What he was really doing was getting onto somebody's frequencies that he didn't have the right to be there on and interfering with their ability to do their job. He thought he was helping. He's a ham, but he was not. He could have just picked up the phone and called the local district and said, I've got a fire to report, right? But he thought it would be more expedient to just make a phone, to just call out on their frequency because he was listening and his transmitter could do so. And the fine was upheld. So, you have to have a really, really justifiable reason to do that. Okay, how are U.S. amateurs restricted in segments of bands where our service is secondary? The entire 70 centimeter band, we are secondary to U.S. government and the military. So if they need to use it, they need to push us off. They could say, you can't use this now. And if you hear operations there, you do not interfere. Maximum peak envelope power for frequencies above 30 megahertz would be 1500 watts. Fundamentally, the reason why it's important to understand this, because your license, even a technician class license, which is the beginner license, right, gives you the ability to use an amplifier with whatever antenna you want, do exactly what that guy did, point it at the moon with 1.5 million watts of effective radiated power. Even with a technician license, you can do serious harm to people if you do the wrong thing. You can kill yourself that way if you're not careful. The maximum peak envelope power for technicians in the HF band segments is 200 watts. Okay, license classes. What license classes are available from the FCC? Technician, general, and amateur extra. No, I don't know why it's called amateur extra and not just extra. Nobody seems to. It just is. What is the normal term for an FCC issued amateur license? That would be 10 years. As soon as it shows up in the license database, it is a valid license. You can only hold one license grant. That's all. And notice that there's actually two things. There's an operator and a primary station license. Your license actually is two parts. One of them is your operator license, which gives you privileges. The other one licenses the station with a call sign. If it happens to be you, you're actually both. But let's say that you are a club station. A club station has a call sign. For instance, the Valley Radio Club here in Eugene is W7 Papa X-Ray Lima, W7PXL. I'm the trustee of that station, which I actually am. I'm the trustee of any time that call sign is being used. However, that call sign cannot be used by anyone who doesn't have a ham license, because it is a station license only. It is not an operator license. It doesn't have any privileges. It just has a location and a call sign. and a trustee associated with it. So there's really two parts to a license. Okay, if it shows up in the database, it's a valid grant. That means you can operate. Who can select a desired call sign under the vanity call sign rules? Anybody with a license can request one. It has to be appropriate for your license class. So notice that we have right here KF1XXX. That's 2 letters and then a number. All call signs have a number. And then a suffix, which is 3. It's XXX. This would be a 2x3 format call sign. Any license class can request a call sign like that. However, this next one, KA1X, that's a 2x1. Extra class licenses only can request those. W1XX, that's a 1x2. You need an extra class license to request that. If you have a 2x2 like KA1XX, you need an extra class license to request that. So basically, you can do with a technician class or a general class license, you can do a 2x3 or a 1x3. N7AAA. That would be valid. Now, it's also interesting to see sometimes I see people who have gotten a request denied. And part of that denial comes from the fact that they don't understand the fact that call signs, it seems interesting that if you look at American aircraft, most airplanes have a tail number that starts with a letter N. And radio stations either start with a K or a W. And there's a reason for that. The reason for that is that the United States in the worldwide allocation of call signs has access to all the Ks, all the Ws, and all the Ns. And those same allocations also hold true for the for aircraft. So you can actually tell where an aircraft is licensed by looking at its tail call sign. You can also tell by looking at, the where an amateur radio license is from by looking at its call sign. The United States also has access to AA through AL. So you might hear an AA3AA. That's an extra class call sign. Every so often, somebody puts in a call sign request to the FCC, which is like Bravo 1 Lima Lima Yankee, or looks like Billy. And the FCC just basically laughs and says, you can't have that because that's a call sign that's assigned to China. Or M1KE for Mike. That's British. Sorry, we can't assign that. So before you do that, take a look at the call signs, take a look at the possibilities, and see if it's even possible to get.
So I have a question.
Uh-huh.
So according to that information you just gave, that means every time you get a new license, like you upgrade to a new license, you have to change your call sign?
You do not. You can select to keep the one you have. No.
Okay.
You can select to keep the one you have.
I would get really confused very quickly.
Yeah. But like if you like Mikey, if you like Mike, if you got an extra class call sign, you're like, oh, I want M1KI. No, you can't have that.
Right. Exactly. Right.
Now, if your name is Will, you could get Whiskey 1 Lima Lima if it was available. Okay, if your license has expired, the grace period it runs for 2 years before you, in which you cannot operate, but your license has not disappeared from the database. You can just send in the renewal form and get it renewed. You have 2 years. Okay, for a club station grant, a club needs to have 4 members to be a club. If the FCC is unable to get to you through email, they can revoke your license. So you always need to keep that updated. You need to make sure that it stays updated all the time. It's also a good idea to have your physical address, but apparently they don't so much care about the physical address anymore. Any vessel or craft located in international waters, if it is documented or registered in the United States, is part of the United States and follows the U.S. licensing process. So if you're on a U.S. flagged ship, you're part of the United States. your license is valid.
Most cruise ships aren't.
Most cruise ships are not. In which case, however, it's interesting because the United States has an agreement with most European countries, which are part of the CEPT, which if you have all the paperwork and you have an extra class license, you get a full European license privilege. So at that point, you need to ask the captain if it's valid. Indecent or obscene language is prohibited. When are you allowed to transmit music? This comes from when they used to wake up astronauts on the space station, or sorry, on the space shuttle. They used to simultaneously broadcast over the amateur band. They used to retransmit all the space shuttle communications, and they would play wake up music to wake up the astronauts. So that's why that rule exists. You can only use it to wake up astronauts. When are you allowed to encode messages to obscure their meaning? The only time, because we're not allowed to encrypt anything and block its meaning, except when we're controlling a space station. A space station is anything 50 kilometers or more up, or an RC craft. The reason being that nobody wants your craft or space or satellite to be given commands and taken over and crashed into the ground. If another country tells the International Telecommunications Union that we don't want these people from this country talking to us, they can basically apply for a block to be placed on communications with that country. To date, the United States, we are allowed to talk to anyone, anywhere. There are only a few countries that we are not allowed, that certain other countries are not allowed to talk to. There was a group of hams from Italy, I believe, that went to Yemen a few years ago, to Socotra Island, to do a de-expedition. And they were told, you cannot talk to Israel because we're still at war with Israel. So they could hear the Israelis and vice versa, but they couldn't talk to each other because the country said, nope, can't do it. When can you receive compensation for operating a station? If you happen to be a teacher, classroom instruction, you can still get paid your salary and use ham radio as part of your classroom instruction. To notify other stations of the ability of equipment for sale or trade, you can't run a business. However, a couple times a week, for instance, you might get onto a swap net and say, I have a radio desk, or I have a computer, or something like that. It has to be somehow related to radio. Broadcasting is intended for the general public. We don't do broadcasting except, see these words again? Immediate safety of human life or protection of property. So basically, we can help out with broadcast news stations if the dam's going to break, like right now. Things like that. And there's no other way to get the communications across. So basically, in case of immediate safety of human life or protection of property, the rules kind of go out the window. So what can you do? Communications incidental to the purpose of the amateur radio service and remarks of a personal character. How's the weather? How's your kids doing? Oh, I got that. I used to laugh. I was 15 and I used to listen, and you'd hear people saying, oh, I got a doctor's appointment coming up this week. And now I'm that person. So, you get on the air, remarks of a personal character. That's me going to the doctor now. So control operator and control types. When can you transmit without a control operator? The answer is never. How about an automated station? Well, technically, if it's an automated station, I'm still in control of it if I'm the trustee. I'm the station licensee. Who does the FCC presume to be the control operator of a station? That would be the station licensee. If it's a club station, who's responsible for its proper operation?
The club?
The station licensee, whoever the trustee of the club is. So if something starts malfunctioning and I'm the trustee, it's my fault. So that means that if something starts to fail, I need to be the one to pull the plug. Who designates the station control operator? The control operator is the person who is immediately responsible for how the station is operating. So if I have a license and it's an operator license and a station license for my own personal radio, I am the station licensee. Here's my station. My equipment is my station. And the operator, I'm assigning myself to be the operator of the station. If those two people are different, they are both responsible for how the station works.
So in general, we are both.
Yep. If it's your own call sign, you've been assigned a call sign, it is your own station and you are the control operator, unless you let somebody else do it, which you can.
Good.
You can say, you
Right.
can use my call sign, but you're the control op.
Okay.
You're allowed to do that. Here's another question. Let's say you have an extra class license and you say, you can use my call sign, come sit at my station, and then you walk out to go use the bathroom. And they have a technician class license.
Nope.
Nope. Because
You're
You have
not
to be
there.
physically there.
well, you don't have to be there, right? But that station can continue operating with technician class privileges. The control operator, the one who's actually in charge of what's happening, their privileges transfer to the station. So basically it would be they would be the control operator, but they could not operate as though they were an extra class station if they don't have that license. Similarly, if let's say a technician class operator is the station licensee, the trustee, and they have a technician class license, and I walk into that station and said, here's my extra class license, and I move over to an extra class part of the band, that would look kind of weird, right? Because then somebody would look on the database and see that the trustee is a technician class operator, and here's that station operating in an extra class band. That's why most trustees are extra class operators, to avoid that problem. Okay, if a repeater, let's say this does happen, somebody gets on a repeater and starts occasionally cursing because they're, mentally unstable or something like that, or have some kind of grudge or vendetta against somebody, and they start messing around with your repeater or interfering with someone, you as the control operator are not responsible for what they're doing because it's being retransmitted automatically. Now, you might take it upon yourself to shut it down so that it stops, but you can't be held responsible for the content. What determines the transmitting frequency privileges of a station? The class of operator license held by the control operator. So again, even if a club station has as an extra class trustee, the person who is the control operator is responsible. This comes up on field day all the time because I had, for instance, somebody who I was the control operator for a technician class licensee who was operating in a general class band, which is fine. But I had to leave the station and go over to the pavilion to grab food, which meant that I had to grab somebody else who had a general class license to come over and watch over them. This just happened last weekend.
That's the only way I could have played in field day is if I had a general with me.
Yep. Under normal circumstances, may a technician class licensee be the control operator of an extra class band station? And the answer is no. That's that exact same thing. Who can be the control operator of a station operating through an amateur satellite or space station? If you are allowed to transmit on the uplink, it doesn't matter where it gets moved. So your signal may be moved to, let's say, 20 meters. You only have a technician. You're not allowed to be on 20 meters, but you're not the one who put it there. You're not the one who moved the audio, so it's not your fault. Okay, the control point. Control point is the point from which the control operator function is performed. If I'm on Echolink and I hit the button that says transmit, that's the control point. That would be remote control. If I'm on my handheld, that would be the push to talk button. That would be local control. Operating a station over the internet is remote control. If you're operating on remote control, that basically means your computer in front of you or your phone is doing something remotely, and you have to be there at all times, and you always and if anything goes wrong, you have to break the link. Automatic control would be a repeater, and I believe this is the last piece of this class. When are you required to transmit? Remember this, repeat it over and over, at least every 10 minutes and at the end. You do not have to give your call sign at the beginning. Most people do. You're not legally required to. The only
In
time
radio, in commercial radio,
it's once an hour.
Radio, yeah, I always had them do it every 15 minutes because it was on the hot clock.
Mm-hmm. Yeah, it's once an hour in commercial, but it's every 10 minutes for us, and at the end. So if you're transmitting signals to a remote control craft, RC airplane or boat or something, you don't have to ID. Instead, what you do is you take your controller and you put your name and your call sign and your address on it.
When you're flying planes, I had a friend of mine that did this.
Mm-hmm.
You have to have on your controller, on the antenna, you put a frequency where your flag is and your call sign.
Yep. And that way you can avoid, hopefully, interfering with other people who are using it as well. When operating in a phone subband, you have to identify in the United States using English. You can have your whole conversation in another language, but you have to identify in English. You can also use Morse code when identifying. That is perfectly valid. Most repeaters actually identify using Morse code because it happens in the background and doesn't get in the way of somebody's conversation. Phonetics, we use phonetics. It's encouraged. It works really well because it removes ambiguity, and it's an international code for letters. If you're using a tactical call sign, let's say you're doing a race and your station is aid station 1 or race headquarters, that is not a call sign. You still have an amateur call sign, which you have to repeat at the end of every communication, at the end of each communication, and every 10 minutes. Same rule. Okay, self-assigned indicator. So either any of these words, stroke, slant, and slash, are all valid. N7JI/3. That is not required, but if I happen to be in Pennsylvania and I want to remove ambiguity, I can do that. That's self-assigned. When you're in another country, however, my call sign, for instance, would be like Charlie Echo /N7JI. The other country's call sign, if you're operating in another country, would go first. Third-party communications. So, Sean, you did a lot of third-party communications during field day. As a third party, what's your job? Oop.
Take messaging, talking, gathering information.
You're the third party. Who's responsible for what comes out of your mouth?
Myself and the licensee.
Actually, you're not. Ultimately, you're not. It's the control operator who is responsible for what you're saying. So, I mean, you might, you're ultimately not the one who's responsible. The control operator and the station licensee are responsible for everything that comes out of that station. So,
the originating message then.
Yep. So I have taken at one time, I was the control operator, and I was at the museum station and working with 10, 11-year-old kids, and I had to slap a microphone out of somebody's hand and say, "You can't say that." Sorry, you can't say that. I'm responsible for it. I knew where you were going. You can't say that. When must the station and its records be available for FCC inspection? If the FCC comes knocking on your door, you have to let them in and let them see your equipment because you have a license and they're responsible for the administration of that license.
Yeah, you don't want to see that white van with the 18 antennas roll up in your doorway.
No, you don't. And for the most part, that will never happen to you. So, well, that's the end of the whole book. We've covered every question, I believe. Okay, Jan, I couldn't read the whole question.
Yeah, most handhelds can get the National Weather Service. You have to know what your local frequency is. You can look at that on the National Weather Service or weather.gov to find out what your local weather station is. Some radios, some of the more advanced radios will actually have the alert feature if you have them in a certain mode. The lower end radios, you can just listen.
That was a question from Zane.
Oh, okay.
He had asked if you can tune into the Northwest or NOAA weather radios to listen to them, like the Oregon WXL96 on the 162.475 megahertz.
Yep. Can you hear this right here?
Sunny. Temperature 69.
Everybody hear that? Okay, so I'm in Eugene. That's 162.400.
That's the radio he was talking about.
So any receiver that has a wideband any receiver that has even a little bit of wideband receive will cover the weather frequencies.
Cool.
And just like our group, we have access to the MERS frequencies. So we have 1 through 5, which you don't have to have a license for.
But I'm going to let you fill in the but.
You were going to put me on the spot.
Was it 2 watts?
You're not allowed to use an amateur transceiver for.
Exactly.
Because MERS, MURS, is 151 to 154 megahertz. There are 5 channels. It is a channelized service. There are specific rules regarding type acceptance for the equipment. They are covered under Part 95, the same way as FRS and GMRS. So if you unfortunately think that, there are a lot of people who will go out and buy a Baofeng and program it for family radio service and GMRS. That is not okay.
Nope.
And if you don't have a ham license, okay, maybe you're not expected to know that. But if you have a ham license, you are really expected to know that stuff. Right?
One of the bypasses is if this comes off,
yeah,
you can't have it.
You can't do it. That's right. And in fact, amateur equipment is covered under Part 97. Part 97 is not a type acceptance. It just says this is usable for amateur radio service. Part 90 covers business band. Part 95 covers FRS, GMRS, and MERS. So even though it's convenient, you can listen. And in case of an emergency, in case of human life, safety of human life or protection of property, yeah, okay, you can probably get away with it. But essentially, if you're, let's say, a lot of people, they might want to carry around a single handheld, like get one of these, modify the frequencies. It'll work. I mean, it will work on your local unencrypted analog fire department radio frequencies, right? If you're a firefighter, aren't you allowed to do that? And the answer is no, because it's not a type accepted radio. It is not permitted to do that. Just because something will work doesn't mean that it's permitted. And maybe without a ham license, you can get away with it and claim ignorance. With a ham license, good luck, because you're expected to understand it a little bit better than that.
Just like we're applying for a GRMS license for the county EMA and FRMS license. That way everything's covered and we can have everything set up.
Yep. And if it means that you have to carry around 3 radios to be legal, well, so be it. I mean, I've got, I've got my FRS radios. I've got probably 4 of those because we have a neighborhood group. We've got a GMRS radio system that we check into once a month, and that covers local communications, simplex, and through our local repeater system. And then I've got all my ham stuff, different radios for different purposes, because I don't want to be violating. If I didn't have an FCC license to violate, maybe I wouldn't be so worried about it. But, you know, I'm expected to know better, I think. So,
You got guys that like to listen to train traffic that have their buddy program in their radios.
listening is fine. And that's the
Yeah,
thing.
you tee
Listening
up.
is fine. You can listen to anything with anything, unless it's cellular phones. You can't listen to cell frequencies.
So if those are programmed on the Wolfbang, as long as you don't talk to on them,
Yep,
it's okay.
Yep.
I would say because my Wolfbang came with it already programmed in.
Mm-hmm. Yeah, and in fact, a lot of the frequencies that come pre-programmed in Baofangs when you get them are definitely not ham frequencies.
There should be a menu setting where you can disable all transmit just to be on the safe side.
Well, the other thing to do is if typically you'll use chirp to program a lot of the Chinese radios, and I believe you can actually inhibit transmit on any frequency on any channel that you've programmed using chirp.
I want to say it has some ham frequencies on it, but it's got a whole lot of other things too.
Yeah, exactly. Well, one of the things I like to do with this handheld is I program in a lot of the en route air traffic control centers and local air traffic, local tower frequencies on AM because they're AM.
We have an aviation radio in our EOC for the purpose, but it's under the county's license.
Those are really expensive too.
No, that's when the county bought it. I didn't.
Yeah, exactly.
And I think somebody asked yesterday about testing. The ham study guide, if you choose to do it online, there are several different organizations that offer testing for $5, $10, $15. It'd be something you're looking into. If you're strapped for cash, that's probably your best bet.
And here, so has everyone been to ham study?
Yep.
Right. One of the cool things about this is where it says find a session. You can click on remote and look at all the different sessions, and it shows you how expensive they are, et cetera, et cetera.
Right now, the cheapest one's the Bayou State. The most expensive one is the $15 because I don't think they can go over $15.
You're not allowed to charge over 15.
Yeah.
And however, if you look at like the ones that are, and I don't know if these are listed as part of ARRL. Here, notice GLARG is free for youth, students with current ID, military, veterans. So that's the Greater Los Angeles Amateur Radio Group. For instance, ARRL charges $5 for kids. The club that I belong to, we pick up the $5. And then if you go through ARRL, there's also another plan for them to, let's see, it's a license grant.
It's a reimbursement, I believe.
Yeah. Youth licensing grant program. So $5 and a one-time grant to cover your $35 application fee for your license. If you're under 18. So basically they make it completely free. They cut, you pay for it and then fill out the form and they send you a check for $35.
Just like our
Is Ham Study the one that has the free sample tests?
Ham Study has full of them. Yeah.
It'll actually show you the right answers too, I think.
Yeah. That's one thing. Yeah, and that's one thing when you test out, you're never gonna know which ones you failed, and they will not tell you.
Nope.
They won't tell you?
Nope.
Nope.
Depends.
Oh.
Well, it depends. Depends on the examiners. I typically
Oh, you
don't,
mean
but
for the test?
yeah. So here's the other thing. Let's say that you happen to be Canadian. I don't know. Do we have any Canadians here today?
I'm actually a Canadian citizen.
Okay.
Yeah.
Well, so do you have an address in Canada?
Yes.
Okay. Well, there you go. See this? ISED, Amateur Radio Exam Generator.
When I retire, that's how I'm heading back home.
So this site on ISED Canada is how I prepared for my Canadian exams. So there you go. Now, it is also true that the United States and Canada have reciprocal license, automatic reciprocal licensing. But if you're in Canada and you're going to be there for a long time, it's kind of nice to have your own call sign. I have to say.
If you take the test online, how do they identify that you're who you say you are?
Okay, so they will, and I've done a lot of these remote exams. Okay, so you've got, excuse me, you've got your camera, and they will ask you to hold up your ID, front and back. It has to match the one that you sent, the one that you gave them when you signed up. If you're a minor, they'll probably ask to see like a birth certificate or something. A passport works, driver's license, school ID possibly. Typically, it has to be government issued, and they will compare your address and stuff like that. And that's how they, that's how they validate your existence and name and stuff like that. But
Yeah, make
then
sure.
the other thing is that wherever you happen to be taking a test, they're going to want to scan the room. They're going to want to look at your table. They're going to want to make sure that nobody can get in, like, oh, there's the door. They want to make sure nobody gets in and disturbs you during your exam. So you're going to want to lock the door. A lot of people actually end up using a bathroom as a result and just lock themselves in the bathroom and sit while they're taking the test.
How long does a test usually take? 10
I've
minutes?
I've seen I've seen people take 45 minutes. I had one person take 6 minutes. It's all up to you. Depends how well prepared you are.
Can you do an online test for a minor and still get that reimbursement for the $35 fee? Or does it have to be in person at one of the places?
It depends on so long as it's ARRL that's doing the exam.
Like if they have their own online testing
Well,
one?
there are groups that are affiliated with the ARRL VEC. Let's see.
I was always told once you have your certificate, your completion certificate, that's ample enough.
Yeah. Here we go. Blah, 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 blah. Let me bring this up and share it. Okay. Oh, you can pick your VEC. Okay. Oh, WM7X is an ARRL group. Okay. So I know they give, here we go, 10 minutes notice is all we need.
How do
So
you affiliated with the VEC thing? Like, does it say it somewhere on there?
if I click on this, yeah, I mean up here where it says
Oh, like the filter?
up here.
Oh, okay.
So like show all the Anchorage exams if you want to work with Anchorage. If you want to work with Glarg, oh, let's do Laurel. Let's see if Laurel's doing any. Nope, doesn't look like it. Let's look at Glarg. So there are a lot of choices. Again, the nice thing is that if you do ARRL, I think it's a pretty much standing rule that they'll that they'll do it for $5. Um, like I said, our club down here in Eugene will reimburse you the $5. We'll pay for the exam. I don't know if other groups will do that or not, but the $35 because you're working through the ARRL VEC, you should be eligible to apply for that.
Okay.
I haven't done it yet. Ooh, late night team. Let's see what they mean by late. Oh, that's not that late.
You also got to remember time zones.
Well, right. Oh, they're in the LA time zone. Okay. So yeah, that's pretty late.
It's 2 o'clock my time.
Yeah. Other questions? And this is a good chance for everybody to just talk about, anything they've encountered in practicing and studying and signing up. I can stop recording too.